everybody, welcome to React Native EU first day of our virtual conference. Welcome everybody, good morning, good afternoon, good evening, good night. Maybe not good night because we are about to start something truly exciting. So in a nutshell, welcome everybody from all sorts of different time zones. We are streaming from Poland, so it is noon right now. Now here is my fancy paper that I will be using. This is my presenting desk. We are live, so all mistakes are allowed. And if I make them, please forgive me. So, why we are doing virtual conference this time? The main reason is of course pandemic that is happening all around the world and all sorts of different travel restrictions. We also don't want to risk your health, so please stay at home, take all the safety measurements and tune in. And this is why we are streaming. So we hope that you will be able to take full advantage of React Native EU no matter what's happening all around the world. Now, we really wanted to make it no matter the restrictions and no matter the pandemic all around, because React Native EU has been always about sharing the knowledge and enabling everybody to learn about React Native internals and all sorts of different interesting concepts and exciting features of React Native. Now, we have Discord, and please use Discord to stay connected with everybody and to ask us questions. The link is down here. You can also use our fancy Twitter hashtag ReactNativeEU, you like that name, to talk about what is happening live and maybe tell your friends that they can join us because maybe there is something that they wanted to learn about and we are streaming that right now. So these are the things that you should remember. And the third thing that you can remember, that you should maybe remember or may be useful for you, is the React Native EU website where we have the agenda with all the talks today and tomorrow. You can use that to kind of stay on top of what is it that we are streaming, because we have a long journey with many hours live. Now,
Powiedz to, że ważne jest, że Q&A zrobimy w tym roku w innej postaci, nie będzie po konferencji zaraz, tylko będzie na naszym podcaście.
See, you like that Polish voice from the backstage? That's Barbara, and she's been helping me run the conference. She's the organizer behind React Native EU from last year as well, and previous editions she's been always around it. So please give it up to Basia. She will not be able to recognize your virtual applause, but I can see her smiling, so I guess we have, made it. So she was telling me to tell you that this time we are not doing a Q&A during our live stream because of technical issues and just to make it easier for everybody to join. So the concept is very simple. If you join our Discord channel, you can leave your questions there and we will answer them as a part of our React Native Show podcast that we are running here at ColdStack. So the idea is very simple. You leave questions, we look at them, we prepare the answers, we answer them during our podcast, which will be streaming a few days or maybe a few weeks after the conference. We will tell you about it, so don't be afraid that you will miss it. You will not miss it. We will do everything we can to let you know that we are doing it. So, all I wanted to tell you before we start is that I hope that no matter the virtual reality that we have these days, you will still be able to take the advantage of React Native EU. And that's why we paid a lot of attention to the quality of the content, the quality of the setup, the quality of the live stream. I'm hoping that it will not blow up during today and tomorrow. And most importantly, we wanted to make a really nice set of React Native talks that will focus on a variety of different aspects of React Native. So the idea here is that those 2 days should help you build better React Native apps and ideally answer all your questions about React Native and all sorts of other questions that you might have as well. Maybe not about the purpose of life, because that's something we're gonna leave for Q&A, but everything else we got you covered. So I think that's gonna be it about opening speech. All I wanted to tell you is that we should start with the first block right now, and that's gonna be cross-platform and architecture. And that block is going to be about cross-platform and architecture. One more thing, because I already started talking about blogs, but I forgot to introduce them in the first place. So the idea here is that we try to group the talks talks in some pairs, in meaningful groups, so that it makes sense to kind of follow them one by one. So if you are excited about performance or if you'd like to learn more about cross-platform, you precisely know when are the talks that excite you gonna happen. So we have those blocks of content and we will be introducing them as we move on to them. So just pay attention to the blocks. You can also look them look them up in the agenda. So the first block is going to be cross-platform and architecture, which is going to be all about, as the name suggests, shipping cross-platform applications on multiple devices and platforms, as well as architecture improvements and exciting changes. And the first speaker, Eli White from Facebook, is going to tell us a bit about it. So let's start with the first block of talks, cross-platform and architecture. Now, before we dive deep into how we can make your React Native app run on multiple platforms, let's learn a bit more about the upcoming changes that are coming to React Native later this year. Our first speaker from Facebook, Eli White, is going to speak at React Native EU for the first time. Last year and 2 years ago, he's been a panelist and he's been answering your questions. And today, he is going to tell you everything you need to know about what's changing in React Native that will make your app run faster and will change the developer experience for better. So let's welcome Eli White.
Hey there, my name's Eli White. I'm a software engineering manager on the React Native team at Facebook. Today I'm going to talk about a lot of the JavaScript changes that we're making in React Native. We've talked about our architecture changes a lot. We've talked about it at previous React Native EU, where we're rewriting the UI layer of React Native. We've talked about JSI and how we're working with new interactions with our JavaScript engine and the improvements and performance benefits we can get there. We've also talked about, last year, Emily gave a talk about the new architecture and the way that we're initializing React Native and some of the performance improvements that we're able to make there as well. But we haven't talked about JavaScript. All of our conversations have been about the changes under the hood, the kind of improvements that will come to React Native from the architecture. But now I want to talk a little bit more about what this means for all of you, from the product side, the JavaScript that you write. How does this actually affect the JavaScript? So today we're going to be talking about a couple of things. I will start with a little bit about the architecture improvements we're doing on the JavaScript side, how we're using code generation to solve a common pain point, and some of the removals and deprecations that are coming as part of the upgrade to the new React Native architecture. So to start with all of this, I want to kind of share how components render in React Native. The JavaScript that you write creates views on the screen, but how does that process actually work? So the JavaScript that you write, it might be a view with props and styles, and the view that actually gets rendered to the screen might be this blue square. So we write this JavaScript and we get this box on the screen. But there's a bunch of different steps that happen between those. So let's go through that. Right before that box is rendered on the screen, we have these methods. On Android, these are Java prop setters that take the value of a property and apply that value with the native Android APIs to the view. Something to notice here is that the JavaScript that you wrote said background color blue, but the Java method receives an integer. So something somewhere is translating between this blue and this int. The JavaScript does some processing and it sends some information to Java. And this information is a payload with these different properties in it. And something you'll see here is that the background color is an int. It's the int that is sent to that Java prop setter. And in JavaScript, we still have this blue. Another thing to notice is that in JavaScript, we have this invalid prop, but that does not show up in the payload. So something somehow, somewhere, knows to convert blue to this int and knows to remove invalid prop. And this thing that knows how to do it is called a view config. The view config is a description of the component, of all of the different properties that it receives, all of the different valid attributes, and how to process them. So you'll see here for accessibility, height, and width that it says it has the value of true. True means whatever you set in JavaScript, just pass that along into native. Don't change it at all. Background color, however, has this object with a process key. And process color, this module, is a function that receives any of the kinds of values of colors that you write in JavaScript, from blue to RGBs to hex values. It takes any of those values and returns a number, and that's the number that gets sent to native. So React knows when you render this view to process all of this information that you wrote in JavaScript with the view config to create this payload. And then the payload is sent to native. It calls each Java prop setter with each method, which then gives us the view on the screen. So I want to go back a couple steps to this view config. We know that these view configs convert from what you wrote in JavaScript to what native expects, but where do these view configs come from? You probably haven't seen them before. So these view configs, even though we at render time are using them to send the information we need to native, we actually create these view configs and calculate them at startup. So at startup, we actually look at these annotations on all of the different properties for these components. And we create this description of the component that is calculated with reflection from the Android code. And we send that description to JavaScript, which then processes this description into the view config that React then uses to know how to convert from view. So one of the problems with view configs is that calculating this is really slow, and we do it at startup. And the problem here is that we are doing it at startup, and we do it every single time. So every time you start the app, even though nothing has changed, we recalculate the same thing. If we go through it, for every component at startup, we have to load that component off of disk. We have to use reflection to read all of the props, and reflection is pretty slow on its own. We build up this object description, and then we serialize this object description, send it to JavaScript, which then converts it to view configs, registers it with React, so that React knows what to do in the future. One of the problems with this is that it means that the more components that you have registered in the app, the slower your startup is. And this is really sad because you might have a ton of components in your app that you never use at startup, and they will slow down your app. These also don't change ever. So what if we could just kind of cache these view configs by putting it into a file in our bundle? That seems like it might solve some problems, but it brings us another problem. And it's that a different platform might have a different definition of the props for the same component. So a view config is the representation of props for a given component on a specific platform. If we look at the different ways that we might write these props on these different platforms, you'll see that we kind of have different ways of defining them that are similar but kind of different. And these are the sources of truth that we use to create these view configs, that we know how to process these components. But because we read these and calculate these from the native code, that means that these can be different. If you've ever run into a problem where a component property behaves differently on one platform than the other, or takes a different value on one platform than the other, this is why. It's because our source of truth is in native. But these aren't the only sources of truth we have for what definition a component takes. We also have our JavaScript types in Flow or in TypeScript. And these need to be consistent as well. And you might have API definitions with Markdown or some documentation about what the component type takes. All of these need to stay in sync, but nothing is keeping them in sync right now. And so you can run into a ton of different problems with as you're writing your applications. So that's problem number 2, is that you have multiple sources of truth. They're both calculated at startup, and they can be different. But the view configs are really only needed for JavaScript to know what the props are. They aren't needed for native or anything else. It's just JavaScript. So the idea of saving it to a file was a pretty good one, but the problem is, how do we keep it in sync with native? So we're going to solve these problems, and we're going to change our view configs from being calculated at startup to no longer have any runtime calculation at all. And we're going to get rid of multiple sources of truth and have a single source of truth in JavaScript. And the way that we're going to do this is with automated code generation. We call it CodeGen. You may have heard of the CodeGen project as part of our new architecture. That's what we're going to talk about. So CodeGen in general is a process of taking some source inputs and generating some artifacts. For us, our source could be any different kind of JavaScript typings that we want. Because we use Flow at Facebook and nobody else does, we knew that we had to support both Flow and TypeScript. We then process those JavaScript types into a shared schema that is consistent between TypeScript and Flow. And then we process that schema and we generate a bunch of code in different places. So this lets us generate those Java methods instead of reading those Java methods. Our type definitions for a component might look like this. And you'll notice that there's some things that are slightly different from what you are used to with types. You'll see this like with default definition. And the reason there is that we used to have these things read from the native code. We used to understand what the default value was from that annotation in native. But since we're defining these in JavaScript, we have to have some of these kind of things defined in JavaScript. So this schema then generates, in Java world, it generates a native interface that our component would then implement. And it can also generate our view config in JavaScript. And that view config will now be part of the bundle at build time instead of having to be processed and calculated at runtime. And one of the great things about this is that it makes sure that our types in JavaScript are consistent throughout the whole system. So there's no more reflection or any calculation at startup. As I said, we're doing this all at build time. We have a single source of truth in JavaScript that ensures that our whole system is consistent and we have the same types all the way through. Now, this process that we've talked about for components isn't just for components. We actually have the same system for native modules. Native modules are exactly the same thing. Native modules are a class with a bunch of methods on them. So we're also defining the type for those methods in JavaScript and generating the native interface to make sure that our types are consistent. So it's the same thing for both components and native modules. One of the other benefits of this is that it also provides a bunch of performance opportunities. We now are defining the input and the output, and we can use CodeGen to change the entire system throughout. We can improve performance by moving some of the CodeGen to C, making some really good performance optimizations there. We can hide all of that from you and other engineers creating third-party components and modules, because the CodeGen means that you only have to write the input and you get out these native interfaces. We can change how we communicate through those on our own. What this means is that if you use typed JavaScripts, you will no longer have cross-language errors. This whole class of problems that we've had in React Native for years will completely go away. We will know if you define something in JavaScript with a certain type, if your build passes, then the native code expects the same types. And this isn't just going to be available for core. This is also just part of the experience of writing components and native modules in the new React Native architecture. So we will provide this for everybody. So we're talking about the new JavaScript architecture today. We've talked about the improvement to startup performance with view configs. We've talked about how we're using code generation. Now I want to talk about what we're doing for removals of old features and some of the things that we're deprecating. This isn't everything that we're deprecating, but it kind of gives you, the goals here is to give you a sense of the things that are important to us and how we're kind of thinking about it and the changes that we're making. Of course, as we get closer, we'll have documentation for all of this. There'll be guides, there'll be everything. And everything that we're talking about here are very subtle features. They're very uncommon, rare, used only for edge cases and often only in library code. It's very likely if you've been writing React Native apps, you've never used these, this will never affect you. And our goal here is to make sure that the JavaScript code that you write can work in the new architecture with as few changes as possible. We have thousands of components at Facebook and hundreds of engineers working every day in these code bases. We can't just make a change and require like everything to change. We have to do things incrementally and have to keep code working as is. So with those disclaimers out of the way, let's talk about it. And I want to first start with the UI manager. The UI manager is how JavaScript communicates with native. In a lot of ways, this is what you think of as the bridge. This is where we serialize how JavaScript communicates with native. This is where we serialize information from JavaScript to native, and we make a bunch of assumptions in this communication path that can lead to race conditions and kind of gives us a cap on our performance. The UI manager is not used by Fabric. We've solved these problems and have a new path, and we've talked about that in some of our previous talks. The UI manager was never meant to be used directly by product code. It was meant to be hidden inside of the implementation of React Native. However, some of this information and methods have kind of leaked out into product code. In areas where we haven't defined really good APIs, we found product code has kind of reached in and used the UI manager directly. So the UI manager is going to be deprecated, like direct calls to the UI manager from product code is going to be deprecated in the next few months as we kind of get closer to our new architecture, and we want to help you be able to migrate off of these calls. So I want to give you an example of what a call to the UI manager from product code might look like. So this is some code calling measure on the UI manager and trying to measure the size of a view relative to a scroll view. And you'll see a bunch of these UI manager calls in these kind of places, and there's a lot of problems with these, and we'll kind of get into that in a second. One of the other examples is view manager commands. This is another method on UI manager. View manager commands are kind of like methods on a component. So if you've ever used like scroll to or flash scroll indicators, or if you have a map and you want to call move to region to zoom the map to a different location, these are imperative methods on a component. One of the problems with dispatch view manager command and these UI manager measure calls in general is that they're completely untyped. So for view manager commands, the arguments to this method are in this array as that last argument, the region and duration. And there's nothing ensuring that those are type safe and consistent with map component or move to region. You can put anything there that you want. So there's for measure, there's an API that's existed for a couple of years, and most code uses this. And so now we're just making sure that when you need to measure something, that you don't call the UI manager directly. Instead, you call ref.measure and use the much nicer, simpler API. So this ref.measure API has existed for a long time, and we're just getting rid of the uncommonly used path. For commands, we are introducing a new API for being able to call commands that solves the problems of type safety, is being able to call those methods directly on the component, passing a ref to that component and the arguments. And this is much nicer. Both of these APIs for both measure and move to region are much nicer. But looking at this commands argument, you might think, well, what is this commands thing? What do I have to write here to get this? And the answer is you don't have to write anything. The magic is CodeGen. So let's go back and look at our example schema, the JavaScript we write to define what the component looks like. We mentioned this already. You have these types, you define the props, you might specify defaults for these different values. But these schemas aren't just for props. We can also define the commands in our schema as well. And so in the schema, as you write your commands, you write these methods that are type-safed, and you export this constant commands. So the CodeGen actually uses this spec and replaces that commands constant in a Babel transform with the method that you have and the implementation for that to work in call to native. This spec also generates the native interface for this command, again ensuring that the type that you write in JavaScript is consistent between the types that your code is being type checked against to the native code that is being compiled against. So let's go back to our original code, our UI manager calls and the new APIs as well. One of the things you'll see in these UI manager calls is all of these different calls to find node handle. And find node handle is problematic on its own. So bonus, we're going to be talking about find node handle. Find node handle is a function that takes a component ref and returns a ID, a unique identifier to a native component. So if we take this view hierarchy, you'll see that we have this RN tester app. And if we call find node handle with a ref to this RN tester app, the ID that we get back is the identifier for this RCT view, for the native component underneath. So the new way of calling ref.measure is a lot cleaner. But there's a gotcha. And the gotcha is that the old way used find node handle, which means that we were able to call this with any JavaScript component, with a ref to any JavaScript component, and it would find the nearest native component to call measure on. Well, with the new API, you have to call, when you call ref.measure, the original UI manager with find node handle, this ref could be any component ref, and ref.measure has to be only a native component ref. So it seems like the old way was actually nicer, but it wasn't. And let me explain why. And the answer is that find node handle kind of sucks. Let's take a look at an example for why that is. So let's say we have a root component and a myProduct component. And root is attaching a ref, getting that ref back, and measuring that product component. So this is what it would look like with UI manager measure and find node handle. And things can kind of get a little bit funky. Let's say that my product expands and it becomes my complex product. And it's in another file and it has tons of code in it, worked on by tons of people, but we're still measuring it. You might think that this is measuring just the outer view, but it's not actually that simple. What is this measuring? Let's take a deeper look. Let's say that my product, the view that it's rendering is the content of the product page. And then someone comes along and they say, okay, I want to update the product page. I want to add a header to that component page. So they wrap it in another view, they add the header, and now when root is calling measure on my product, they're measuring the size of both the header and the content. Okay, maybe that's what you wanted. Maybe you wanted to understand the size of the whole page. But originally you were just measuring the content. But okay, this is fine. And then some engineer comes along a couple months later and they say, we have this view that is just wrapping these two elements. We don't need that anymore. There's this new thing called React Fragment. So they modify that to get rid of the extra view. Well, what they didn't realize is that root was measuring the nearest view. And that was the wrapper view. So now that root is measuring my product with find node handle, the ID that it's getting back is the ID for the header component, which is not the ID for the content component, which is what they probably originally expected. So this is pretty kind of scary. Your product code can change with what seems like a simple refactor. And this is why find node handle is bad, because it requires this global understanding about all the different parts of your code base. And one of the things with React is we really want to enable you to only have to think about the specific part of your code base that you're working in. This means that it's easily broken by refactoring. If you move things around, if you reorder things, if you kind of change nested views to fragments, all of this can break. It's also slow. Find node handle has to traverse the React tree from the ref that you passed it to the nearest identifier. And being able to traverse this tree is slow, but we also have to maintain this tree in memory, which means that the code size for React and the memory size of tracking this whole hierarchy is extra just to support find node handle. So find node handle is going to be deprecated in React Native soon. We still have a couple of use cases for find node handle that we don't have new APIs for, and we'll make sure that all of those exist before find node handle is deprecated. But if you see find node handle calls, you might want to kind of think about whether there's a better way to do it. There often is. Find node handle is actually already deprecated in React DOM. It's not called find node handle in React DOM, it's called find DOM node, but it's deprecated for the same reason. And they recommend on the React website that instead of using find DOM node, that you use ref forwarding. So let's go back to our example and take a look at what ref forwarding means. So instead of calling UI Manager measure on find node handle with my product, we want to attach a ref. The ref that we get from my product is a ref to a JavaScript component. We want to get the ref to the content view. So React forward ref lets us wrap our component and attach that ref directly to the content view. So now when you attach a ref to my product, you're getting the ref to content and not a ref to the JavaScript view. And now that component ref in root is actually a native component ref, we no longer need to call find node handle. We already have the ID for the native view, which means that we don't need to call UI Manager measure either. We can just call component ref dot measure. This is much cleaner, much nicer to work with. So forward ref is great, and it solves a lot of the problems that we have with find node handle. It gives us an explicit API and enables local reasoning. You can understand the code that you're changing. You can see that your component is attaching a ref to a certain component, and as you move things around, you can keep that being connected. Forward ref can also be type checked, so you know that when you attach a ref to my product, that you're actually getting back a native view ref. So all of the core components in 0.62 use forward ref, which means that when you use view or text input or anything like that, and you attach a ref to them, you're actually getting a ref to the native component. So these are all of some of the the built-in React Native core components. And you'll see that those are all marked with forward ref. When you attach a ref to them, you get the ref to the native view that they render. So as I mentioned, find node handle is going to be deprecated fairly soon in the next couple of months. And we'll help you with more documentation about all the different use cases and how to migrate off. But this has been kind of a taste of the most common things that we've seen with find node handle. So in the new JavaScript architecture, we've talked about how we're improving startup performance by no longer recalculating view configs, how we have a single source of truth that's JavaScript for our components and our modules. We're using automated code generation to take that single source of truth in JavaScript and generate the native code that uses the same types, giving us end-to-end type safety throughout the whole system. We've also talked about how we're removing the UI Manager and we're deprecating both access to UI Manager because Fabric doesn't use it, and how we're giving some of the uncommon calls with find node handle and UI Manager proper supported APIs. We've also talked about how we're removing find node handle to help you enable to have encapsulation and use Fabric compatible APIs. That's all I've got. Thank you so much. My name's Eli White. You can find me on Twitter at Eli_White. Thank you.
Thank you, Eli. That's been really insightful, and I'm really excited for what's going to change in React Native. Now, let's move on to the next talk, which is all about desktop. Historically, we've been talking in terms of React Native about iOS, Android, and other mobile platforms. Microsoft recently has been really heavily invested into making React Native run on desktop. Not a surprise, they are outdoors of Windows, which controls majority of desktop devices, which runs on majority of desktop devices. And today, Steven from Microsoft is going to tell us about everything we need to know when it comes to running React Native on Windows and, surprisingly, on macOS. So let's welcome Steven.
Hey everyone, my name is Steven Moyes, and I'm a program manager on the React Native team at Microsoft. I'm super excited to virtually chat with you all today and give you some insight into using React Native to build great apps for desktops and dual screens. At last year's React Native EU conference, my friends EJ Lane and Micah Lewis described how you can use React Native to build highly performant, great apps using React Native for Windows. This year, I'll share how we're making it possible to bring your apps not just to Windows, but to macOS as well. I'll finish up by briefly touching upon how we're making it possible to make your apps dual screen aware and target even more emerging devices like the new Surface Duo Android device. This talk will be structured in a Q&A format. I will ask a question that the team has heard from the community, and then I will answer that question. Let's get started. Our first question is, what does Microsoft bring to React Native? Since you're attending this conference, you probably already know a thing or two about React Native. You know that it has a huge developer community and that hundreds of apps are built using React Native. You know that React Native apps are truly native apps, which means that they have the best user experience, they have the best performance, and that they have accessibility built in. At Microsoft, we really want to amplify those benefits and help bring React Native and your apps to even more endpoints and devices. We know that developers like using JavaScript and TypeScript to create native experiences for Android and iOS, and we want to extend that awesomeness to desktops as well. We want to participate in the community as co-contributors and help make React Native a really great platform, not just for mobile, but also for desktop. This leads us into our next question, which is, can I use React Native to reach desktops? Now, if you're called into this presentation, you probably already know that the answer is yes, you can absolutely use React Native to target desktops. But when you think about React Native, you're probably more familiar with building native apps that target iOS and Android. What we're doing is we're working to extend the number of endpoints and the number of users that you can reach by including support for Windows and macOS as well. Now, when I say that we're supporting Windows and that we're supporting macOS, what I really mean is that these endpoints are really just extensions of the React Native core. They extend the shared common components that are used already in Android and iOS, and they just add additional support for Windows and macOS. To help demonstrate that Windows and macOS support is built on top of the same common core, I'm going to show an RSS feed demo app running on macOS. Now, you might recognize this sample from this year's Build conference, where my peer Kiki Saint-Onge built this app from scratch. I'll include a link at the end of the presentation, and I'd encourage you to go check out that video, but I wanted to quickly introduce you to this app because I'll be discussing it throughout the presentation. Here, I've got the RSS Reader app running. I've cloned it from the repo, and I've followed the steps in the README to get it up and running. The app is pretty basic. It has an RSS feed on the left and the actual blog post rendered on the right. Although it is pretty simple in function, it embodies several important features, including the ability to run on both desktop platforms in Windows and macOS, as well as including some important native modules such as the WebView component and the RSS parser module. One additional thing that I would like to mention is that Microsoft and Facebook are co-collaborating on bringing React Native to desktop. It's not just Microsoft. In fact, there's a whole team within Facebook working on React Native for desktop, and they're working to make React Native for Desktop a great endpoint for building industry-grade applications. That ties into the next question. Who is using React Native for Desktop? I'm going to highlight just a few folks, but I just mentioned that there is a dedicated team within Facebook working on React Native for Desktop. Part of the reason that they have a dedicated team is to support the Messenger app on desktop. The Messenger desktop team is building a delightful native video calling experience that targets Windows and macOS, and they're using React Native to help them build their app. Although they were originally looking at Electron, they're using React Native to unlock system capabilities that simply can't be achieved using Electron. That's why the team is looking at React Native for desktop. Let's take a look at another example. The Xbox Beta app on PC lets you browse, manage, and download games to your PC. As a storefront, user experience is very important to the Xbox team because they want to have users deeply engaged with their content. In this video, you see the rich animations and multimedia capabilities of the Xbox app. Similar to Messenger, the Xbox app initially explored using Electron, but found React Native helped them make a super performant app that had a great user experience. In their tests, the Xbox team found that memory consumption went from 1.6 gigs all the way down to 350 megs. CPU usage spikes went from 50% down to 30%. And users are taking notice. In a survey, the team found that over 95% of users surveyed noticed that the app's performance was the same as or better than before. Not only that, the team was able to port their entire app from Electron to React Native with just a few devs in a few short months. Now let me give you a more recent example, the Microsoft Store on Xbox Console. The Xbox team was able to use their JavaScript and React Native for Windows skills to make a highly performant store experience for the next generation of Xbox consoles. Now, although this isn't a desktop experience, I really wanted to highlight this app because it shows the power of React Native for Windows. You can use React Native for Windows to target even more endpoints, and it's not just mobile anymore. Think of all the customers that you can target using React Native for desktop. Now, hopefully these examples got you pumped to try building a React Native app for desktop. The next question is, how can I get started? Getting started building a React Native app that targets Windows and macOS should feel very familiar if you've ever used the existing command line tools. What I'm going to do is I'm going to show a quick demo using the CLI to build a macOS app from scratch. The first thing I'm going to do is visit aka.ms/reactnative to see how to get started. There are links here to get started with both Windows and macOS, so I'm going to click the macOS link. The first command I'll put into the terminal is npx react native init my project with a version. This is the same step that you would take if you're writing any old React Native app. I'm going to speed up time through parts of my demo. Note that I've also got my development environment already set up for React Native development. I've already got Node, I've already got CocoaPod set up, I've already got everything set up as if I was writing just a regular old React Native app. Now, see, the instructions for Windows and macOS are shown on at the end of the CLI. Next, I'm going to go into my project directory and do npx react native macOS init. This will install all of the modules that are required for creating a macOS application and run it locally. Again, I'm going to fast forward through a few of these pieces. And finally, once it's all done, I will just do npx react native run macOS. This should feel very similar to if you've ever run for iOS or for Android or for Windows. And what this does is it builds the app, it launches the Metro bundler, and then in a few seconds here, we should see the macOS app running. Almost there. There we go. Look, we've got a Welcome to React standard app. Let me resize it here so that we can see what's going on. And then I'm going to, in classic demo fashion, make a change and see it live. So I'm going to open VS Code here. And then I'm going to navigate to app.js. And let me move this over here and bring this to the foreground. And then scroll down, and I'm going to replace some text here. And then replace this with hello from React Native Mac OS. Awesome. And then we can see the change. Now on screen, I'm including the steps that it took to build a macOS application, as well as the corresponding steps for Windows. We're trying to make these steps as consistent and familiar as possible. And for full instructions, you can visit aka.ms/reactnative to learn more. Now, once you get your app up and running, you might be asking yourself, what modules are available for React Native for desktop? Now, one of the awesome things that differentiates React Native from other platforms is the vast library of native modules that you can use to add functionality to your app. There are hundreds of modules that encapsulate a ton of different features, from navigation to camera to Bluetooth to more. There's modules for everything, it seems. And I wanted to quickly highlight reactnative.directory, which is a website that catalogs a ton of these modules. You can search and filter on reactnative.directory to find modules that fit your needs. Additionally, the team has worked closely with Expo and the community to add filters that show Windows and macOS modules. Although we're always working to add support for new modules, one thing that I should mention is that adding desktop support to existing modules is still a work in progress. We've got quite a few that I've listed on screen, but there's still more work to be done. Why is that? Because most modules were written for mobile first, the user expectations for these modules sometimes requires rethinking how the module works on desktop. Modules that aren't purely JavaScript and that have native code written in Java or Objective-C, they require native implementations for Windows and macOS as well. Fortunately, it's fairly easy to adapt an iOS module for macOS, since a bunch of the code can be shared. On Windows, you'll have to add Windows-specific code written in either C# or C++. Now, one specific library that I'd like to discuss is the Fluent UI React Native library. This feeds into my next question: how can I get Fluent Design in my React Native app? For those of you who need a refresher or don't know what the Fluent Design system is, it's really Microsoft's point of view about how to build great user experiences. If you're familiar with Google's Material Design or Apple's Human Interface Guidelines, this is kind of a similar concept. Fluent Design is our shared DNA and a way to bring principled design, innovation, and customer needs together into one open design system. The Fluent Design system really is a holistic system for building productive apps no matter what endpoint you choose to target. It includes everything from guidance and fundamentals, through to design toolkits, through code and UI libraries, and documentation. Whether you are a designer or a developer, the Fluent Design system can help you build really great user experiences. Since we're talking about React Native, though, I want to focus on the Fluent UI React Native library. The Fluent UI React Native library is a supplemental set of components and styles that are layered on top of the core React Native platform. These components are customizable, they're theme-aware, and they have accessibility built in. I want to give you a few quick examples. The first example is a primitive button. Button is really a fundamental piece of the native UI experience, and therefore looks and feels natural on each device. What I'm showing you on screen is that Fluent UI is providing a consistency between devices in terms of accessibility, stylability, and end-user experience. Other primitives, like text, should also feel natural on each device. In this example, the text elements use the native fonts for each platform, like Roboto on Android, San Francisco on Apple, and Sego UI on Windows devices. What Fluent UI brings here is a consistent sizing and type ramp. Finally, some experiences should look consistent across devices, like the persona coin, which represents you as a person. You don't fundamentally change based on which device you're using, and neither should the representation of you on that device. Fluent UI helps encapsulate this thinking and this logic and helps you build productive experiences by combining stock React Native as well as Fluent UI principles into a single library. This helps you really create productive apps that feel natural on every endpoint, whether it's mobile or desktop. Finally, I'd like to touch just a little bit about how you can bring your app to even more devices, including emerging devices such as those with 2 screens. The next question is, what about dual screen devices? Now at Microsoft, we're really dedicated to helping you increase your app's reach to more endpoints and to more users, including not just those on mobile and desktop, but those on emerging form factors as well. One such emerging form factor is the dual screen mobile device, like the Surface Duo. Now, since the Surface Duo is just another Android device, you can of course use React Native to build apps for it. But what Microsoft is providing is an additional set of dual screen aware APIs and controls that will allow you to build really great experiences that are dual screen aware. One such API is the 2-pane view component that helps you build apps that are dual screen aware by having 2 panes. Another API is dual screen info. This provides lower level information about the state of the app. Is it spanned? Is it, on both screens or just one? As well as orientation information about the device. You can visit us on GitHub to get started with both of these APIs. Now let's take a minute to see some of these new APIs in action. I'm going to bring up the RSS feed app here running on the Surface Duo emulator. I've updated the app to be dual screen aware using the 2-pane view control. I've placed the RSS feed list in the first pane and the web view in the second pane. When the app is running on just a single screen, all we see is the list in pane 1. But when we make the app span both screens, we can see that both panes render. Since the Duo emulator is still in preview, you might notice some rendering glitches, and we're working on fixing them, but I wanted to show off this demo. Let me recap. We've now seen the RSS feed app running on macOS, on Windows, and on the Surface Duo. We also saw how the Xbox team is bringing their store experience to both Windows and the Xbox console. Hopefully you can imagine how you can now use React Native for desktops and the new dual screen APIs to extend your apps beyond just mobile and reach so many more users. The next question is, where can I go to learn more? How can I connect with the team? I'd like to highlight a few resources to help you get started. Throughout this presentation, I referenced the RSS Reader application which my peer Kiki Saint-Onge helped create for the Build 2020 conference earlier this year. If you want to learn more nitty-gritty details about how the RSS Reader app is constructed, how it was set up, how to integrate several native modules, I encourage you to go watch the video at aka.ms/m365sk119 to learn more. I also wanted to call out to my friends Micah and EJ, who presented at last year's React Native EU conference. In their talk, they described Microsoft's overall strategy around React Native and also described how apps like Word leverage React Native to build really cohesive experiences across mobile and desktop. Finally, I'd like to mention that all of these resources and more can be found at aka.ms/reactnative, which acts as our one-stop shop for all things React Native at Microsoft. From the website, you can learn about how you can get started building React Native apps that target Windows and macOS, as well as API documentation, native module documentation, information about Fluent UI React Native, and more. If you'd like to connect with the team, I'd recommend reaching out to us on Twitter at React Native MSFT. We're active both on Twitter and on GitHub, so please do reach out. Whether you're starting from scratch or extending your app's reach to the billions of users on desktops, we are excited to see what you build using React Native. Thank you so much for watching. My name is Stephen Moyes, and I hope to catch you around. Goodbye.
Thank you, Stephen. That's been a really insightful talk, and I'm really excited that Microsoft is also investing in other platforms than Windows, including macOS that I'm using today. So that's great. Now let's move on to our next speaker, Kudo. I know Kudo from React Native community, and he's one of these developers that I really admire for their knowledge of React Native internals. I know him from long discussions about C++, GSI, and other core React Native pieces, and he's been contributing to React Native for a while, making these pieces play nicely together. So I'm really excited that he decided to give a talk today, his first talk, about what he's been contributing to, which is GSI and other core React Native pieces that allow making new platforms, new targets for React Native easy to maintain. So I know that this is his first talk and he's been really stressed about it, but I think it's going to be great. So let's welcome Kudo on our virtual stage and let's learn about the shared implementations and how we can run React Native on a new platform.
Hello everyone, this is Kudo Chen from Pre-Recording Video. This is my first time to have a talk in such a public event and in such a form. When I speak to the camera and pretend that there are other people, I feel that being a YouTuber is really hard and programming is easier. My topic today is extending React Native to the next platform. This was the title when I submitted a React Native EU code for paper. At that time, I was not sure if I could finish my proof of concept in time. Well, as some of you may already know, the proof of concept was done. So, ladies and gentlemen, today I will show you extending React Native to a Flutter-like cross-platform architecture. Before that, please let me introduce myself. My name is Kudo Chen, and the Twitter account is Kudo Chen. I'm a React Native enthusiast from my limited of work time. I have some side projects like React Native VA, which is a VA JavaScript engine replacement for React Native. I really love React Native's architecture that we could extend the fantastic React.js declarative component-based UI development into other platforms. This saves me from the traditional mass-based or then MVC with fat controller mobile development. I would like to see if I could truly write React Native on every platform. My current full-time job is at CloudMoza, a startup to do the Puffin browser, a cloud-based browser. And it is modified from Google Chrome open source project, Chromium. So I got a little familiar with Chromium stuff. That is the background that I could introduce this topic today. Okay, let's go back to our topic. Today we could already write React Native on some platforms. We have the officially supported iOS and Android, Microsoft open source layer out of 3 platforms for Windows and Mac OS. There are also React Native Dawn on web and React Native Desktop on Qt, but they were not updated for a while. In my opinion, in the past days, to add an out-of-tree platform is difficult. From the bridge, native module manager, and to the UI manager operation queue, that requires pretty much work. However, React Native is an active project. To follow upstream changes is really terrible, especially for individual maintainers. Thankfully, the upcoming React Native architecture redesign is the core team had more cross-platform insight. The JSI, Turbo Module, CodeGen, and most importantly, Fabric. As you may heard from the past months, with these new stuff today to extend React Native to a new platform, I do believe things will be easier. The best way to learn and clarify the details is to have a hands-on experience. I learned JSI from React Native V8, and in this project, I learned some details about Fabric. I will show my understanding to you later. 3 years ago, Google open sourced their cross-platform solution, Flutter. People often compare React Native with Flutter, and I always be curious about the reason people to choose Flutter. Some people choose Flutter because they don't like JavaScript. Well, I don't have comment for that. Some people choose Flutter because they think Flutter has better performance. And I was thinking that with the Beauty architecture from React Native, it is possible to port React Native into a Flutter-like solution. People said that Flutter is fast because they don't have native views and directly use GPU to draw UI graphics. In fact, Flutter uses Skias is a foundational drawing library. What I'm going to do is using Skia to draw React Native views. There are some goals of my proof of concept. First one, it will be as minimal as possible, simply to support views, images, and tags. There will be no interaction and no animation. Second, the code should be cross-platform and avoid to write platform-dependent code. In the proof of concept, I will demonstrate in macOS, but in theory, the outcome could be extended to other platforms easily. The third one, avoid to patch React Native's code, hopefully to be a true out-of-tree platform. Let's start our journey. We will write an out-of-tree platform from scratch. Because React Native code is written by C++, on the way you may need some C++ background. First, I'm going to introduce Skia. Skia is a cross-platform 2D graphics library. It supports various GPU backends such as OpenGL, Mantle, and Vulkan. Besides Flutter, Skia is also be used in Google Chrome and Android. Skia focused at graphics drawing, so it don't have concept about view hierarchy or how a native window is being hosted. I mean, for NS window in macOS or UI window in iOS. However, to integrate Skia into React Native, I need those stuff. Thankfully, in Skia example code, there are some simple implementations. They are SKApp. I will borrow SKApp into my proof of concept. Next, it's the building tool. Facebook internally uses Bug to build React Native. Skia uses GN and Ninja. Both Bug and GN are cross-platform component-based building systems. We should choose one. At the beginning, I tried to use GN because I am familiar with GN, and it is really hard for me to port Skia Builder into Bug. Skia's building script is really complicated. On the other hand, a critical problem is that React Native Fabric heavily relies on a Bug-specific feature. The header namespace and its portive prefix. That makes me hard to use GN for Fabric. At last, I turn to use Bug for the whole system. And for Skia, there is a trick. I used GN and Ninja to generate pre-built libraries and use Bug's pre-built CSS library feature to integrate. After building React Native and Skia successfully, we could start to write code. The diagram is the first version of the architecture. The blue part, React Skia app, is the main program. It is actually the Skia Hello World code to draw some simple graphics, and it has some underlying SKApp window and SKApp layers. On the other hand, on the right-hand side, there is an instance which is to host most important React Native module, the Facebook React instance. To initialize React Native instance, 4 components are necessary. Instance callback, which is to receive some events. We could use the default empty implementation. Module registry is responsible for legacy native module, and we could leave it empty as well. We should implement the remaining 2 components, JS Executor Factory, about the JS JavaScript VM, message queue thread, about message loop. Message queue thread is responsible for message loop, or in the name test queue or test runner. You could see there are 3 pure virtual functions to implement. I had some choices before. The first one, to write a handy C++ simple message loop from scratch, or to port Chromium's message loop or message pump here. And the third one is to looking for some other C++ cross-platform solution. At last, I chose Foley, simply because we already have Foley and I also want to learn more about Foley. The Foley event bus is a good fit for our requirements, and there is a problem that event bus is not yet supported to build in React Native OSS. Let's add the support. And then I added two box targets, fully async and fully synchronization. Because they rely on other third-party libraries, libevent and OpenSSL, I also used the same strategy before: download, pre-build, and add box pre-built CSS library. There is a final implementation just to call two functions: run in event-based thread and run in event-based thread and wait. It's really simple. The other React Native instance component is JS Executor Factory. It is the factory to create JavaScript VM, which is named JS Executor here. As far as I know, in the past days, this was difficult as we should implement a bridge here. From the newer React Native, JSI Executor is a cross-platform and unified solution toward JS Executor. Since we are on macOS, we could reuse existing JSC runtime and integrate with JavaScript code. After React Native instance is initialized, we could then execute the JavaScript bundle. And then I use the load script from string function. If there are any JavaScript errors, there will be C++ exceptions. I'd catch the exception and write to log. The JS bundle is very simple. It has some views, actually just two views, two nested views and with different color. The button is the CLI command to generate a bundle. After executing the JavaScript bundle, we should see some JS errors. In the example, the error said the platform constants module is missing. Okay, it's time to Turbo module. Let's have some brief introduction for Turbo module and JSI. I think Eli from React Native Code team will mention more details in his talk. From my understanding, JSI, the JavaScript interface, which is an abstract of common JavaScript operations. The underlying implementation relies on JavaScript engine's C++ interoperability. You could use JSI to create JavaScript scalars such as number, boolean, string, or object. Moreover, JSI hosted function is that you can declare a function in C++ and export it into JavaScript world. When you call the JavaScript function, the implementation is actually in C++. JSI hosted objects concept is similar, but it's for JavaScript object. Turbo module is based on JSI to support native module system that you may be familiar before. Native module, you could have tons of methods, and some of them could even return promises. Let's see how we scratch a Turbo module. Take platform constant module as an example. How many properties we need to implement? The first one is to reference from JavaScript spec, the JS file, and see the flow type. The other one is to reference pre-generated native spec, and it is really hard to read. Sometimes writing JSI code is really troublesome. And that is in fact React Native CodeGen did. CodeGen will save us from writing troublesome JSI code. It will use flow node to reference JS flow typing and generate corresponding native code. This ensures type safety and doing JSI correctly. React Native's Turbo module system also did a lot for cross-language interoperability. For example, wrapping Objective-C or Java to JSI C++. For our system, since we are all in C++, we could write Turbo module by JSI directly and not to use CodeGen. This is a code snippet of platform constant Turbo module implementation. For the final Turbo module manager, we have these modules. Some of them are unimplemented empty modules, simply to make JavaScript happy to find this module. Some of them need further constants or methods, but most methods are also no OP. Time module is a special one. It is an underlying implementation of JavaScript set timeout or set interval. For this, I could also use fully event-based supported function, schedule at. The last one, UI Manager module, is a legacy workaround to make JavaScript UI Manager happy. The actual UI Manager will be Fabric. Even more, in the future React Native's bridgeless mode, it seems UI Manager module is not necessary. Finally, there are no more daisy arrows. When executing the JavaScript bundle, it's time to add Fabric and integrate with Skia. Well, in my opinion, Fabric is more complicated than previous part. The most critical module of Fabric is the scheduler. To initialize Fabric scheduler, two dependencies are worth to mention. The first one, scheduler toolbox, and its underlying event bit factory and component registry factory. The other one is the scheduler delegate, and sometimes called the mounting manager, which is responsible for component operations such as creation or deletion. Since there are no interaction in my proof of concept, I only implemented the creation operation. Let's go for each part. The event bit factory is also related to matched loop implementation. From my understanding, they are UI thread matched loop and original shadow thread matched loop. This part is the only platform-dependent code from my proof of concept. The reason is that the platform UI thread matched loop is encapsulated in Skia's SK app. So the workaround is to use Apple Core Foundation's CF run loop get main to get a singleton UI matched loop. The actual code is copied from React Native with iOS. Component registry factory is the place to put all components registration. And the component descriptor is the class to describe the shape of the component, which could include name, unique ID, and shadow node related stuff. For each component, we should register with a concrete component descriptor. Taking view as an example, its component descriptor will be view component descriptor, and you could find this in React Native source code. And CodeGen will also generate component descriptor from external component. Fabric's component only covers shadow stuffs. A shadow node or shadow view is like a virtual shape of a platform view. It is smelling like a virtual DOM. Well, to integrate with true platform views such as UI view in iOS, we need an extra place to associate shadow view with platform view. In my proof of concept, I also put the associations in the component registry factory. In React Native Skia, we had some RSK prefixed component stubs, and the RSK component provider will create corresponding RSK component. RSK component have an instance, and RSK component have an interface unpanned that support to add Skia drawing command into Skia's SK canvas. As a slide shown, we will call drawRect for React Native's view, drawBitmapRect for image, and drawSimpleText for text. After we initialize the component registry, we could go further with the mounting manager. We could get a shadow view mutation here. The mutation is to describe if there are new views to be created or views to be deleted. As mentioned earlier, I just implement the create mutation in my proof of concept. In a mutation, we will get a shadow view. There are some critical properties in shadow view. Let's have some more examples. Component name or component handle could be used to get or create a component by previous component registry. Props and state have some meaningful information. For view, we could get such as background color here. And the layout matrix is about view spawn or position after calculated from Yoga Engine and from your styles. So we don't need to integrate with Yoga here. They are covered in Fabric. There is an example to show how to get the information from Shadow View and Draw by Skia. That is from my RSK component view unpaint function. The first step is to get the background color from the Casty Shadow View props. Then create the SK pen from the color. Shadow View's layout matrix is where we could get the frame position and frame bounds, and we could create a SK rect from the frame information. And that's just to draw the rect with the SK paint. Then I started to integrate previous SK app window into Fabric that introduced the RSK surface window. It will be attached to Fabric and Mounting Manager. RSK component could then interact with it. For the proof of concept, I have support for some simple view, image, and text. As a code snippet shown, there is a background view, an image to show React logo, and a text that React Native loves Skia. And then there is the final result. For me, it was an exciting time. I really scratched the platform from ground up. The final component diagram is like that. There was an instance to host a Facebook React instance and JSI Turbo Module Manager. At the right-hand side are Fabric-related stuff: the scheduler, component view registry, underlying RSK components, and Mounting Manager. RSK components are previous SK app layers. RSK service window is previous RSK service window is previous SK app window. And now they are integrated together with an instance. It's near to the end of my talk. People may likely to ask how about to launch React Native Skia into real world. My answer is that we still need a lot of work. As you know, I did not implement most of Turbo modules such as networking and WebSocket. I did not implement all Fabric's shadow view mutation, so view should not be updated after some props changed. More importantly, there are still some other missing critical steps such as input event, heat testing, and animation. And that is from React Native's point of view. On the other hand, for Skia, as mentioned earlier, Skia does not have view hierarchy concept. We should add a true layer system instead from SK app example code. The layer compositor will be a critical part. Some optimization, like you could ignore Skia command outside of your viewport. In Flutter, there is a module called Flow to handle the layer composition. And Flow is pretty much like Chromium's CC compositor. They are both critical and complicated systems. Even we are still far from production code, I will open source my proof of concept code after the conference. Hope if there are someone who interested in this project and we could do it together. In the final of the talk, I want to leave this question. After adopting Skia, will React Native could be as fast as Flutter? The answer may be yes, and maybe no. How do you think about Android Native View's performance? How do you feel about the performance of Android Web View or Electron? Both they use Skia to draw graphics. So the most important thing is how we implement the system, and it may not simply related to Skia. Always profile and see how much we could improve before coming out a conclusion. Thank you, and hopefully to see if the dream to write React Native everywhere comes true one day.
Thank you, Kudo. That's been great. And honestly, every time I touch C++, I feel like I'm doing magic. So that's Really exciting to see what you've been working on and see how you can make use of these tools to run React Native on a new platform. Now let's move on to our next speaker, Brent, a friend of mine, and I'm really excited for Brent to speak at React Native EU because of the fact that React Native EU is a virtual conference this year, it's been possible for Brent to take part in our great event. So Brent today is going to talk about Expo, a toolkit for building React Native apps that he's been making, and he's been part of it for many years. Now, every time React Native developers start a new project, there is this question: should I use React Native or should I use Expo? Today, Brent will show us that you no longer have to answer this question. He will demonstrate that you can integrate Expo services, libraries, and tools to your React Native project at any time of the development lifecycle to improve your developer experience and just ship your apps faster. So let's welcome Brent on our virtual stage and let's learn about everything that Expo provides and how we can take advantage of that today.
Hi, my name is Brent and I work at a company called Expo and I live in Vancouver, Canada. When a developer first gets started with React Native, a common question that comes up is Expo or React Native? What the developer really means to ask, but does not yet have the vocabulary to express, is should I use the Expo managed workflow? Let's take a look at the word managed to understand what this means. Heroku provides a fully managed platform for app deployment, which means that you write your application and they take care of hosting it and all the problems that come with that, such as SSL and certificate management, server maintenance, security patches, scaling, etc. In the context of React Native app development and Expo, the word managed takes on a slightly different meaning, but the spirit is the same. The complexity of some layers of the stack are handled for you. In the Expo managed workflow, you write your application in JavaScript or TypeScript, and we manage the native layer. This means that the developer does not write or directly modify any of the native code in their project unless they send a pull request to the Expo repository to change it for everyone. Upgrading between different React Native versions is easy when you're just writing JavaScript because you only need to take into account breaking changes to the JavaScript-facing APIs. The trade-off is that you can't add or change native code without leaving the managed workflow by ejecting. In addition to managing the native layer for you, we provide you with tools to easily share development builds of your project with the team. We help you to manage your app signing credentials. We build your binaries for distribution. We help you to upload those builds to the stores. We give you the tools that you need to update your apps over the air, to send push notifications, and to collaborate with your team across all these tasks. The moment you initialize a new project, you have a professional workflow for building, deploying, and updating your app. This is huge. It can save your team weeks of work and even more in maintenance over the lifetime of your app. But many developers need or just prefer to own and be responsible for the native code in their apps. Because of the way people tend to think about Expo or React Native, the tendency for developers in this category is to think that they can't use Expo. If this is you, it might come as a surprise to you to learn that we've made most of our tools and services actually work great for any React Native app, and not just for Expo managed apps. You can initialize a new unmanaged project, or bare React Native project as we call it, with Expo CLI or with Create React Native App. This will give you a project that's based off of the React Native CLI template with some additional configuration to set you up with many of the same tools as in managed apps. If you eject from the managed workflow at any time, we will create the native iOS and Android projects that Expo is managing for you. And in just a few minutes, you'll be ready to resume building your project from the same place that you left off. So we started off with the question, Expo or React Native. Then clarified that to, should I use the Expo managed workflow? Which is another way of saying, should I let Expo manage my app's native code for me? Even if the answer to this is no, or not for this app, or not anymore, you may still ask, should I use Snack for prototyping? Should I use Expo tools for React Native Web? Should I use the Expo SDK libraries in my app? Or should I use the Expo notifications service for push notifications? You may also ask whether you should use the Expo updates service for OTA updates, or coming soon, the build service for managing app credentials and creating builds. And then a little bit further out, but also coming, is the Expo development client package. So let's look at these tools and services and how they apply to your React Native app. At this point, everybody using React Native probably knows what Snack is, but in case you don't, it's like Code Sandbox for React Native apps. Open snack.expo.io in your browser, and you have an in-browser development environment to quickly experiment with ideas on the web and in an embedded iOS and Android simulator and emulator. You can also open Snacks on your phone in Expo Client or in a local simulator. You can drag and drop assets like images and fonts, and you can add libraries to package.json, as long as they're supported in the Expo Manage workflow, that is. Hit the save button, and you can share the URL to your Snack with a friend. Press the code icon, and you can embed it in your blog or in some documentation. We've also seen teams use Snack for previewing and interacting with components in their internal design systems. So, should you use Snack? Yeah, you probably should. When you initialize a React Native project with Expo CLI or Create React Native App, which is CRNA for short, it supports web out of the box by installing React Native Web, React DOM, and using the Expo Webpack config. This Webpack config is similar to React scripts from Create React App, but tailored specifically for React Native apps. It provides polyfills, aliases, and other defaults that make using iOS, Android, and web work in the same code base out of the box. If you need to extend it, you can inject the Webpack config and index.html and several other hidden configuration files by running Expo Customize Web. When you're ready to ship your app, you can run Expo Build Web, and we'll create an optimized bundle that can easily be deployed to a hosting provider of your choice. An example of a website out in the wild that uses these tools is React Native Directory. It uses an adapter we built to integrate nicely with Next.js. In addition to the Next.js adapter, we provide adapters to integrate with Gatsby, Electron, and Storybook, so you can use those tools for your web app and share components between platforms where it makes sense. Check out the examples of these integrations by running npx-crna and choosing template from expo/examples, and then select the example that you'd like to try. The examples default to managed Expo projects, in part because it's a lot quicker to install and easier to maintain a lot of these examples when they're just packaged JSON files and JavaScript files. You can just run Expo eject to create the native projects if you like. You can use the Expo HTML elements library to render semantic HTML elements on the web and fall back to native equivalents on iOS and Android. For example, H2 will render to an H2 tag on web and a text component on React Native for iOS and Android. Expo Match Media is a useful polyfill for the browser window.matchmedia API, so you can use React Responsive for cross-platform media queries. And of course, libraries in the Expo SDK work great on the web. The Expo SDK is an extended standard library for React Native. It is a set of libraries for iOS, Android, and web that are written in TypeScript using consistent API conventions. Like other React Native libraries, they expose operating system capabilities such as audio, video, camera, file system, permissions, calendar, contacts, media library, OpenGL, web browser, and so on. The libraries are all named with the Expo prefix rather than the React Native prefix, but they are React Native libraries. Now, it's worth noting that the Expo prefix was probably a mistake because it makes developers think that the libraries only work with Expo, which is commonly understood to just mean the Expo managed workflow. The intention on our end was to indicate that the libraries support the platforms that we support at Expo, iOS, Android, and web, but we can see how this is confusing. Another important thing to note is that the Expo SDK libraries are built on top of a module abstraction that we call unimodules. So you'll need to install the React Native unimodules library in your project before you use them. Alternatively, you can create your project with Create React Native app to have React Native unimodules installed and configured out of the box. React Native unimodules makes it possible for libraries within the Expo SDK to depend on native code from other libraries in the SDK. For example, Expo Camera will use Expo Permissions for requesting permissions and Expo File System for writing files. A common concern that developers have when they install React Native unimodules is that there are a lot of interface files. These define the interfaces that modules use to depend on each other. So Expo Camera requests a module that implements the permissions interface and then calls the permissions interface methods on that. You can exclude all of these interface files manually if you like. However, you will need to include those that are being used by modules in your app. However, it's not necessary to actually exclude them in most cases because they're just small header files and you don't really have to worry about them increasing the size of your app. Some libraries that I lean on extensively are Web Browser, Auth Session, Camera, Haptics, and File System. One of the most interesting libraries in the SDK is ExpoGL, which powers TensorFlow.js for React Native and works with Three.js and React 3 Fiber, so you can build some really nice cross-platform 3D experiences like games and little 3D whimsical flourishes for your apps, like the cute spinning planet Earth in Shopify's Shop app, for example. Most libraries in the Expo SDK stand on their own, but Expo notifications and Expo updates have optional dependencies on backend services that you might want to lean on to make your life a bit easier. One caveat before we continue is that the features I describe as being currently available for these services are entirely free to use and will remain that way. But when I talk about what we're working on to improve these features, those improvements will be rolled into an upcoming paid service offering featuring the next generation of these services. Expo Notifications provides a cross-platform API to fetch push notification tokens and to present, schedule, receive, and respond to local and remote notifications. The Expo Notification Service abstracts over the platform-specific notification providers APNS and FCM and provides a simple HTTP endpoint to send push notifications to both platforms. To set up Expo Notifications in your project, enable the push notifications entitlement in your iOS project, and create and configure a Firebase app in your Android app. Now, if we want to use the Expo Notification Service instead of APNS or FCM directly, we need to upload our server credentials because the notification service needs them in order to send push notifications on your behalf. The iOS side can be handled automatically if you run Expo Credentials Manager in your project directory and select Add New Push Notifications key. On the Android side, you'll need to copy the FCM API key from the Firebase console and add it to your project by selecting Update FCM API key in the Credentials Manager. In your app code, you can now call notifications.getExpoPushTokenAsync rather than notifications.getDevicePushTokenAsync to get your Expo push token. The method returns a token string that's formatted like Expo push token with square brackets and an ID. To send a notification to the device, you make a post request to the Expo push send endpoint with a JSON payload like to, title, body, and a variety of other potential fields. We recommend using one of the existing Expo Server SDK libraries to do this in production in order to help with batching, and it provides a nice typed interface in many cases. But an easy way to give this a try in just a few seconds without creating or configuring a project is to open up an Expo Notifications Snack demo in Expo Client. Once you accept the notification permissions, you can tap Press to Send Notification, and this will send a push notification post request directly from the app running in Snack. This temporarily only works on iOS and Snack, but it'll be resolved soon once we finish transitioning entirely from our legacy notifications API in the Expo Client. The notification service makes it super easy to get started with sending push notifications in your app. The next generation of the notification service will include a web notification dashboard, support for sending actual notifications for web apps as well. And so if these sorts of features are important to you, you might want to consider using another push service. That said, even if you don't use the service, Expo Notifications might still be the best React Native library for notifications, and it's certainly worth taking a look at next time you want to add local or remote notifications to a React Native app. Expo Updates fetches and manages code and asset updates to your app from a remote server. In other words, it's a library for over-the-air updates. If you initialize a new app with Create React Native App, it'll have Expo Updates already configured and ready to use. If you initialize a project with Expo CLI, it'll be configured appropriately for your Expo account as well, which just saves you a little bit of work. The most common way to use Expo Updates is to host your app JavaScript and assets on the Expo Update service. So when you run Expo Publish inside of your project, it will build your app JavaScript bundles for iOS and Android and upload those along with any of the assets imported from your code to S3, and then the updates will be served to your users through CloudFront. The update service lets you publish versions of your app to different release channels, so you can easily target specific binary releases and environments. For example, you can run expo publish -- release channel production to target a binary that points to the production channel. Binaries that point to other release channels will not receive these updates. You can also perform commonly useful release operations like rollbacks and promotions. You can configure update behavior like whether to wait before starting the app, to download an update, or to download in the background. We configured this app to wait up to 4 seconds to download a new bundle when the app opens. And if it doesn't succeed in that time, it transitions to downloading in the background. But in many cases, you probably want to load your updates in the background or manually control the updates in your app code and provide some prompt when the update is available. You may want to opt out of using the update service if you work at a large company with strict hosting policies. In this case, you can run Expo export with the public URL flag, passing in a path to where you plan to host the update bundle. Then take the bundle and upload it to that location, of course. When hosting your own updates, you'll need to implement some sort of logic around release channels, rollbacks, promotions, and other things on your own. And so we recommend using the release channel, the update service if possible. The next generation of the update service will feature incremental rollouts and deep integration into the Expo Web dashboard. Currently, when you publish a new release, it's available immediately to all users, but it's often preferable to roll out incrementally to limit the damage in case of a significant regression accidentally sneaking into the build. Web dashboard integration will give teams easy access to release history and provide an interface for controlling releases and rollouts, which should be really valuable because, as you can see, there's a lot of information that you need to take in. We're now getting to the part of this talk where I'll be letting you in on some projects that we're working on that aren't quite ready for public use yet, but I'm really excited about them, so I just wanted to share some information with you now. So, what if all you had to do to create app and Play Store builds for a brand new React Native app was run one single command? No manual configuration required. The command would take care of prompting you if any information is needed, acquiring the appropriate app signing credentials for you, and then kick off release builds on dedicated build machines and let you know when they're done. After you completed this process once, your colleagues could also run the same command and everything will just work for them too. This is how the build service for managed Expo apps has operated over the past few years, and now we're working on bringing the same experience to every React Native app. The idea is that it should just work out of the box for most React Native apps, and you can customize the build process if you have more specific needs. The build service will be deeply integrated into the web dashboard and with the update service, so you can see at a glance which binaries are live and which releases are associated with those, along with an update history, a timeline of activity in your feed, and a dashboard for managing credentials. We're also thinking about the problem of getting your builds to internal testers so they can run them on their devices. This is very easy to do in the managed workflow. You can just share a URL to your app, and a team member can open that URL in the Expo client to test it out. What if you could pass in one flag to the build command and get a URL that a team member can use to sideload your app through ad hoc or enterprise provisioning profiles on iOS, similar to something like Hockey App? What if you could build a version of your app with an Expo client like Shell so that you wouldn't even need to download a binary most of the time to test the new build of the app? The Expo Client app is like a web browser for apps built with the Expo runtime. And the Expo runtime is the React Native and Expo SDK native code that your JavaScript executes against. Every React Native app has a native runtime. So what if you could take your app's native runtime and build a web browser around it? What kind of workflows would that unlock for your team? One idea is to publish a preview build on each pull request. You can set this up easily in the managed workflow by using the Expo GitHub action and configuring it to publish and comment on the pull request with the URL and a QR code. The ability to do this makes mobile development feel much more like web development in really the best way, and it brings us closer to the develop, preview, ship workflow that Vercel has democratized on the web. Developers using the managed workflow love the Expo client and often avoid ejecting whenever possible in order to be able to keep using it. We've also heard from large companies in the React Native space that they've built their own web browser type app for internal usage. So we've been working on a development client library that you can install in your React Native app, and it will give you an Expo client-like experience built around your own native runtime. For apps that lean heavily on JavaScript and where the native runtime doesn't change often, this could be a great fit for your development process, both for fully testing builds of your app and for prototypes. If your app has significant business logic written natively and the native runtime changes often, it may be more useful for just sharing prototypes. Now, what if you could use custom native code in the managed workflow? If you wanted to use a library that wasn't included in the Expo runtime, you could add it to your package JSON and then kick off a new development client build and distribute it internally. This would be a great option for lots of developers whose needs aren't currently met by the Expo managed workflow because they need to install a library to get the functionality they need for their app. They can stick to just writing JavaScript code and installing off-the-shelf libraries to expose native features where needed. This is something we're thinking about and working on the foundations to support, like the new build service and development client library, and we hope to be able to share more with you about this in the near future. At Expo, we provide developer tools and services that help you build, ship, and iterate on React Native apps, so you can focus on delivering value to your customers. If you use React Native in your app, we can help, and I hope I've given you some ideas for how you might use Expo tools or services in the future. So maybe instead of Expo or React Native, we'll start seeing a lot more Expo and React Native. I encourage you to check out what we have available today and follow along with some exciting updates in the coming months at blog.expo.io and on Twitter @Expo. Thank you.
Thank you, Brent. That's been really insightful talk, and I'm really excited about everything that you are building at Expo. I've been using Expo libraries and tools for a while now, and I think they make our lives just easier and let us ship apps faster. So now let's move on to a quick coffee break that happens virtually now. So in other words, we now all have 15 minutes to grab a coffee and get ready for another blog. Now, before you drop off, make sure to tweet about our live stream using React Native EU hashtag to let your friends know that we are broadcasting live and that they can join us and learn about React Native together with us. Don't forget to join our Discord channel using the link down below here and leave any questions that you have to the talks that we have already presented or that we're gonna present in the upcoming blogs. We will have a special Q&A session during React Native Show, a special podcast that we are hosting, and that's where we will answer all your questions. So that's everything that I wanted to tell you right now. Let's move to a quick coffee break and be back here in 15 minutes for another block of React Native Talks. This conference is brought to you by ColdStack, the React and React Native development experts. Meet us at coldstack.com.
Wake up in Wrocław? Get up and get at 'em. React Native EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. We'll see you next year. Calling all builders and tinkers, the doers and linkers, the ones who create it from scratch and the ones who code a clean patch. The code ninjas, the toolers, the thinkers, and don't forget the seasoned drinkers. Your open source lovers, your time tracking haters, the JavaScript junkies, and the wild bug wranglers. Your community is here and it's waiting for you. It's the first of its kind and it's called React Native EU. Core contributors and insights and networking and knowledge, all for React Native, it's in our language. Find us in Wrocław, Wrocław, Wrocław. Difficult to pronounce it. Your good vibes are here, go on and announce it.
Welcome back after the break. I hope that you had a great time. As you can see, I still got my morning coffee, so I'll probably fill it up in the next break. So now let's move on to the next block, a performance block, which is really important because it's not only important to be able to ship your app fast on many platforms, but what is important is that the app at the end of the day runs fast, right? Our next speaker, Parashuram from Facebook, is going to talk about making your app faster by optimizing JavaScript pieces. Now, if you think about previous talks by Ram, he's been usually talking about deep, low-level internals of React Native, explaining why things are slow in the first place and what you can do to make it run faster. Today, he's going to talk about JavaScript side of things, where, in his opinion, are a lot of low-hanging fruits. So he will show us what we can do at a very low cost, very quickly, to optimize our apps to make them run faster. So let's welcome Ram on our virtual stage and let's learn what we can do to make our apps run faster.
Hey everyone, my name is Ram and I'm here to talk to you about React Native Performance. If you're curious about the title, yes, there was a take one before. Back in 2019, I had attempted to give a similar talk on React Native Performance at Chain React Conference in Portland. In that talk, we had specifically looked at the different scenarios where performance was important and had focused on one scenario around the startup time of the application. In the talk, we had discussed what defining the startup time means and how we could optimize the different parts of the startup to ensure that the app loads up faster. We had dug deeper into what actually happens when a React Native app starts up. We had spoken about native part of the startup and the JavaScript side. We had ensured that we would mark the start and end of each phases just to understand when something starts and ends. Because React Native is a native application, it does have all the work that needs to be done as a part of a native application. Turbo React package was a good example of how we could defer some of the work in loading native modules and view managers to the time when they are actually used. It was also in 2019 Chain React Conference that Facebook announced Hermes, the JavaScript engine. Hermes is a JavaScript engine to run JavaScript in a React Native application. Since its announcement, a lot of people have used Hermes and have seen significant performance improvements with their React Native applications. Of course, we had also touched on the JavaScript side of the world, covering from anything starting on the initialization of JavaScript modules, lazily loading them, to optimizing the components themselves. We had looked at techniques like inline requires and React Profiler to help us with optimizing JavaScript. Finally, we had also spoken about the network module. We had discovered that we didn't have to wait all the way for JavaScript to start up to make a request in JavaScript. We were able to make the network request on the native side of the world, and by the time the network request returns, JavaScript is ready to receive the response and render it. This way, we were saving significant amount of time during the app start by ensuring that the network actually happens in parallel. Additionally, to improve perceived performance, we were also looking at things like enabling mock data or mock screens that show a good loading screen and help us to have a good transition between the loading state of the application to when the application shows actual data. All in all, though we went very deep in the app start part of it, we did want to also look at some other scenarios. That's why I'm here, to keep that promise and do a second take at talking and discussing about React Native performance. Additionally, if you go to the React Native website, you would notice that a lot of people who write React Native applications are JavaScript developers. The amount of JavaScript code in a React Native application that a user writes is much, much higher than native code. And the presentation from Chain React mostly focused on optimizations in the native layer. In this talk, I definitely want to focus a lot more on the JavaScript side of the world and look at some of the low-hanging fruits that we can leverage to ensure that our application starts up faster and has a buttery, smooth user experience. Navigating to the performance documentation on the React Native website, you may also see a bunch of topics which I had not covered at my previous talk. In this talk, I definitely want to go a little bit deeper into some of them. One of the peculiar things you would notice is whenever someone talks about performance, they talk about FPS or frame rates. This was something that I had not covered previously, and I would like to make amends. In fact, looks like FPS or frame rates are so important that it's mentioned 7 times in the React Native documentation, not including the 2 times when the words buttery smooth UI or responsive UI is used, which is kind of synonymous to frames per second. So that's basically why this talk is titled React Native Performance Take 2, where we'll be talking about profiling frame rates and frames per second. Let's get started. So let's start with a very simple React Native application. This application is supposed to emulate a typical React Native application where the state changes cascade through the entire component tree. In this application, you have a bunch of buttons that you can click, which updates a counter state. And then you can add multiple child components. And as you continue adding the child components, the state kind of trickles down to all of these child components. You can also click on the child components to ensure that the state trickles back up to the parent, giving an idea of what a typical up-down state management system in a React Native application can be. In any React Native application, to understand how smooth the React Native app is, people typically open up the debug menu and start the performance monitor. This shows up a nice little window at the top right corner indicating the FPS for UI and the JavaScript threads. Before we jump into optimizing performance, let's actually dig deeper and understand how these numbers are measured. How does React Native actually get these numbers, and then look at what we can do to improve these. As you may have guessed by now, React Native basically runs on two threads. The UI thread, where most of the user interface elements are displayed and rendered, and the JavaScript thread, where most of the business logic is rendered. If you want to calculate frames per second, you would typically look at any of these threads and try to calculate the starting time of a frame, or every time a frame happens. Basically, what you need is a callback on every frame where you record the start time of the frame. Once you have this information, you can then aggregate it to figure out how many frames were present in a second and show that information across time. React Native FPS counter does something similar. It has a frame callback that the Android or the iOS system gives React Native, which is called on every frame. This frame callback records the start of the frame and uses that information to display the UI FPS. On the JavaScript side, it also calls the JavaScript update callback to understand if there was any JavaScript method running during that frame. In fact, what it actually does is it looks at the bridge or the UI manager to see if there was any JavaScript executed or if any batch was processed from the bridge when a frame happens. In case some JavaScript is taking too long, the next batch of JavaScript calls from the bridge cannot be queued, mostly because JavaScript is single-threaded. As a result, you would not have JavaScript running on that frame, indicating that the JS FPS goes down and JavaScript on that frame was dropped. This is how the two numbers at the top right corner are displayed. You may also be able to see this information if you open up systrace. While you don't see the exact FPS numbers, you'll be able to see what exactly happens at each instance as your application continues to work. The way systrace works is that you add a start and an end marker for any event, and they are displayed across a timeline in form of a flame graph. At the start of the talk, I promised that I'd be focusing on JavaScript this time. So let's dig a little bit deeper into JavaScript to see what kind of information can we get. As you can see, the JavaScript systrace is not very dense. The reason for that is for any systrace event, you would have to add a start marker and an end marker. Unfortunately, there are not many built-in markers for JavaScript, and you as a developer of a React Native application may have to add a little more. This kind of gets cumbersome as you cannot simply add markers at the start and end of every function. With that in mind, wouldn't it be simpler if the JavaScript system had a mechanism similar to the UI thread, where you could get like a callback on every frame, and then you could just record what was happening? Though the JavaScript thread doesn't understand frames because there's no UI associated with it, you can definitely do some kind of sampling at regular intervals just to understand what happens during that point of time. Because this is JavaScript, one function calls another, and you can actually not just get the top stack frame or function, but the entire call tree just to understand what methods were called and what was the flow of logic. Now here, you can also start approximating from the start point to the end point, indicating that this was the entire time when the JavaScript function ran. Now, of course, the JavaScript function might terminate in between the time intervals, but that's okay because the time interval is usually narrow enough that this would not make a lot of difference. What you could do is you could start drawing bars across these to indicate when does a function start and end. And you can see that soon this starts to become like a flame graph. This flame graph now helps us understand how long a JavaScript function runs and what are the functions that this specific function calls to get us the entire call tree. This lets us understand how fast or slow any JavaScript function is executing. This is the basic principle of a sampling profiler. Almost all JavaScript engines today have a sampling profiler. In fact, using a sampling profiler to debug performance issues on the web is very common. People typically open up the Chrome browser, go to the performance panel, and the JavaScript information that they get is from the sampling profiler. React Native also has sampling profilers both on iOS and on Android. On Android, if you're using Hermes, you could open up the debug menu and select Enable Sampling Profiler. This starts a sampling profiler, and then you can continue to act on the application, going through the workflow that you think is not smooth or is not responsive. Once you're done with this, you can stop recording, and you would now have a file that has the sampling profiles, which tells us what are the different kind of functions that are being called at those regular time intervals. The React Native CLI also has a command to pull this and convert it in a format that you can display in Chrome. You can just do React Native profile Hermes, which goes, looks at the files, pulls it out, applies source map to it, and gives it to you in a format that you can open up in Chrome. Once you open up this file in the Chrome performance panel, you can actually see a flame graph like this. Zooming into it a little bit, you can see the different functions that are being called, including the time that any native function could take. Now, this is pretty interesting because native functions here, colored in purple, let you figure out how much time is JavaScript waiting before you make a call to native function and get back from it. Additionally, there are a bunch of other colors here to help you distinguish between React and React Native's built-in functions, native code, and any userland code or any code that you might have written. This is an interesting visualization to understand the JavaScript thread and how busy it is. You can look at the various functions at any given point of time and can determine if a function takes too long or is being called too frequently. The Chrome profiler view also has ways to filter this according to the function that's called the most number of times or the function that takes the longest duration. To give credit where it is due, I would like to call out Jesse and Safal, two students who built this amazing tool. Jesse and Safal built this as a part of the MLH Open Source Fellowship, and special thanks to Yanni, who helped mentor them and made this possible. This is possible not only on Android, but also on iOS. On iOS, you would open up Safari and attach to the JS context running on the emulator. Then you can go into the timeline and start recording. Once you've started recording, you can continue to use the app as usual, going through the typical flows that seem to be unresponsive and collecting samples. After you're done, you can stop recording, and the view here displays the different samples, including the times and the call stack. Unfortunately, the format here is not super simple to parse, and I believe that this is a good open source project for someone to convert the iOS sampling profile to something similar to the Android one. Using this information, you can actually look at what's happening on the JavaScript thread. However, this can be a little bit noisy because it shows you every single JavaScript function. If you had to take a step back and if you wanted to see the bigger picture, another option that you could use is the React profiler. The React profiler is a sampling profiler specifically for the React applications, and it gives you more information about what happens internally on the React side of the world. Earlier this year, we enabled Flipper for all open source applications. You could use that to show the React profiler. Now, the way you would do it is you would install Flipper from the Flipper's website, go to the DevTools and click on Profiler tab. Then you can start recording and continue to perform your actions. Once the profile is displayed, at the top you see the list of commits that React goes through, and at the bottom you see the flame chart for each of the commits. You can look at the bars that are the tallest to see what exactly was going on. You can also see them in a ranked fashion to understand which is the most expensive function that was called. On the right side, you also have information around the parts or the reasons why an update happened, and this is super important because you can use this information to add the should component update method to ensure that all updates are happening only when they are required. This part actually shows you the props that cause the re-render or the state that caused the re-render. And the React Profiler is an amazing tool if you're a JavaScript developer. All the knowledge that you learned debugging and making your React application performant can actually be reused here. Flipper also has some really amazing tools, including a way to view images and see the sizes in which they were downloaded, a network inspector, and a way to understand the native layout. If you haven't checked out Flipper yet, I would highly recommend trying out Flipper, and it's a great developer companion tool for React Native. Flipper also supports multiple plugins. So that was the JavaScript thread, and now we have kind of gotten an insight into what exactly keeps the JavaScript thread busy. Armed with that information, let's try to figure out how do we optimize this. When someone says that their application is unresponsive, this is typically what happens. Let's say there's an on-press event. As soon as you press something, the event handler gets called. But in this case, let's assume that the event handler does a lot of things. Now, if another on-press occurs during that time, that cannot be immediately scheduled. That's because JavaScript is single-threaded, and you'll have to wait for the previous function to complete before the next event handler runs. The most common manifestation of this process is when you click on things and things do not respond, but the UI continues to work well and the scroll works. The reason for that is that the event handler is no longer running, but the UI thread is just as responsive because it doesn't have to wait for the event handler to complete. The way to solve this is very similar to the way we solve it on the web. What we typically do is instead of running the entire function in one go, we try to split it up into two parts. The first part is the part that is giving feedback to the user that the button has been pressed, which typically could include like a pressed state, updating state quickly or something like that. The longer part is actually added to a task queue to be executed later. This task queue basically sets a timeout, which in turn calls the native timing module. This indicates that once the timeout fires, we can pick up the task and start executing it. Of course, because this is a task queue, you can have multiple tasks added to it, and all of these will be picked up once the set timeout fires. Now let's say that a second on-press happens. Now because there was nothing running on the JavaScript thread, you can immediately execute the on-press event. Now it does look like the on-press will be executed and the user will get feedback that they have pressed something immediately. The timer can actually fire in the middle of the on-press, and that's okay. Because in this case, the timer event will only be appended or added to the queue once the on-press event handler is completed. And the timer itself will pick up the next item in the task queue and add it. With this approach, we have been able to give immediate feedback to user actions like touches, and yet are able to process all the functionality that is required for the actual event handler. The way you typically do this is using an interaction manager. In React Native, you can say interaction manager.run interactions to run something after the events have been completed. As you can see, interaction manager is a JavaScript module that simply uses set timeout for scheduling. You could also go use set timeout or set immediate or request animation frame instead of having to use interaction manager. However, note that if the amount of time taken to run something in a set timeout is long, that might go and delay few subsequent user interactions. And that's why it's better to manage it all to ensure that you're always ready to receive a user action and have a way to cut down tasks into multiple parts so that you can execute them within a frames time frame. This is about responsiveness, but there's also the other part of Buttery Smooth UI, which is about animations. Let's talk about animations a little bit now. How does animations really work? So in the ideal world, you'd kickstart an animation, and then on every frame, you try to get the latest position, which could be either the X or Y, or it could be any other attribute, to ensure that you have regular updates to adhere to the smooth curve that you care about. However, this is not always possible, and in practice, the JavaScript thread is usually not this free. What could typically happen is when you're running an animation, this could be interrupted by any other JavaScript function that's running, and the animation unfortunately gets scheduled only after that JavaScript function completes. This would result in the animation frames being called in irregular intervals, resulting in a stop and go animation. This is a very janky or a stuttery effect and is not the best user experience. Now, wouldn't it be simpler if all of the animation calculations were happening on a separate thread? Well, it is, and I mean, you can technically pick all of the animations and move them to the UI thread. The way you move it is how set native driver works. The only downside of moving all of these animations to a separate thread is that you can now no longer control them or cancel them. All of your logic needs to be preset when the animation is created, and you will just have to wait till the animation is complete. Canceling an animation becomes a lot trickier now. Now, this is great if you have to animate one or two elements. What happens if there are multiple elements? Adding animation like this and set driver kind of gets hard. And React Native actually has this hidden gem called layout animation that lets you animate groups of objects together. Layout animation itself is actually pretty simple. You just turn on layout animation, and the code that runs is something similar to this. It just says whenever a layout has to be updated, which is the X, the Y, or the width or the height, layout animation is triggered. And if layout animation is enabled, and if the element can be animated, instead of just changing the X and Y or width and height, you animate them. The only downside here is that this is an all or nothing, in a sense that you cannot selectively pick and choose elements that you care about. Layout animation is actually a great way to ensure that your animations are not janky and they are smooth, because you're basically offloading all of the animations onto the UI thread. So to summarize, in this talk, we basically looked at multiple problems that could potentially make your application slow. On the JS threads, you have things like unresponsive clicks, navigation that lags primarily because the navigation animations are calculated using JavaScript, or timers. The interesting thing about timers is that if you remember the example around interaction manager, set timeout was actually calling into a native module. Remember that as soon as something goes over to a native module, it goes through the bridge, and the bridge might have other JavaScript functions. So having multiple timers in your JavaScript application can be one source of an issue. And if your timer interval is too short, you may as well just do it on the native side to ensure that you have a smooth experience, and the timers are called at predictable intervals. We also looked at animations, which kind of lies between JS thread, and how we could offload it to the UI thread to make it smoother. However, there are other problems like image scaling or overlapping translucent view that are not really JavaScript related, but live much more in the realm of the UI thread. Now, a good example here is changing the width and height of an image makes the iOS operating system do a lot of computations to ensure that the scaling happens. Now, if this is something that you do often, you might want to rasterize it, or basically say that you might want to put it in the GPU memory so that you are not actually affecting the layout as much. The same is true for overlapping translucent views where you're playing with opacity. While all of these are common problems in terms of ensuring that your application is smooth, one part we haven't covered as much is scrolling lists. The key thing about scrolling lists is that it's not just about responsive UI, it's also about memory usage. At the end of the day, most mobile applications eventually end up being a list of lists. There might be a really, really large amount of data, and the trick here is to ensure that you only display the data that's relevant, thereby conserving memory, and ensuring that because you're conserving memory, you're not doing extra computation when you have to add or display new items in the list. So I would love to jump into scrolling lists, but looks like I'm out of time. So I guess we should probably wait for a take 3 of my version of the talk. All jokes apart, I think scrolling lists is a little more complex topic, and it might warrant a talk of its own. That's pretty much all I had. This is my Twitter handle. And if you have any questions or concerns regarding React Native performance, I'd be more than happy to talk to you. In fact, recently, I've been helping a few folks and companies with one-on-one sessions where I discuss the React Native performance problems, and in turn, they blog about it to ensure that everyone else in the community benefits. So if you have a performance problem in a React Native application, I'd be happy to talk to you, with the caveat that once you've solved the problem, please do blog about the experience so that we can make the React Native documentation better and also help others to learn from your experience. That's all. Thank you. Bye-bye.
Thank you, Ram. It's been a really amazing talk, and honestly, I finally understand a lot more about sampling JavaScript, profiling, and all those systrace insightful things that usually are very, very tricky to grasp at the first sight. So now let's move on to our next speaker, Omri from Wix. Now, Omri is going to talk about performance as well, but he's going to focus on sort of native-related optimizations. Now, if you don't know it, Wix app is running on a million devices, and performance is very, very critical to them. Wix did a lot of great native-focused libraries in the past, including React Native Navigation, which back in the day was focused on delivering native-like experience for navigating, something that was very important for them in particular, but also for the entire community. And today he's going to talk about the performance optimizations that they did in their app, including improving performance, startup time, gestures, and all those and all sorts of other optimizations around that topic. So let's welcome Omri to our virtual stage, and let's learn more about the optimizations that they have done at Wix internally.
Hello, and welcome to my talk, Performance Does Matter. My name is Omri, and I'm so excited to be here today at my home, broadcasting to you from Tel Aviv, Israel, talking to you virtually and being able to communicate with you even though we have this corona crisis. Honestly, I would prefer to fly to Poland, meet all of you in the conference. But anyway, I hope everyone are happy and safe home. So before I start, a little bit about myself. I'm currently leading the mobile platform at Wix. I originally came from iOS background, and today I'm mostly around React Native applications, focused on architecture and performance. You can find me on Twitter at Omri Bruchim. And today I'm going to talk about how to improve your app performance, which, if you don't know yet, it affects your rating and revenues of the application and your business. I will share some tricks and React Native feature we are using at Wix in our mobile application to improve the experience for our users. Keep in mind that most of the principles I will present today are relevant for all mobile applications, not specifically for React Native, but the practical example that I'm going to show is about React Native. So let's jump in. I want to start with a few motivation slides before we are going to dive deep technically. So did you know that according to a research conducted 2 years ago, every 1% decrease in startup time can increase your app visitation retention by 0.27%. It basically sounds like a small number, but 20% increase in your application startup time with application of 1 million users can increase your retention by 5,000 people. It's amazing. We can actually say that when a mobile application performance doesn't meet the user expectation, there are very high chance to abandon the application, resulting in loss of potential revenue. Another fact that is even more interesting research is a measurement of level of stress in our daily routine. Compare between solving a math problem, waiting in line in the store, or waiting for a screen in our mobile application to be loaded. So apparently mobile delays make us more stressed than watching a horror movie. You understand? Our user feels so much frustration when they need to wait for something. So a few things we need to keep in mind. We are talking about performance in mobile applications. First, we want the users to come back to the application, open the application again and again every day and spend their money on us. The second one, we want to give our user a sleek experience. The application should feel good in their hand. We should give them a holistic experience of the application. We want our upload fast as possible. No one wants to wait 10 seconds for an application to load. They will simply tap on the home button in iOS or back button in Android and continue with their day, not waiting for the app to be loaded. And we need to remember that it doesn't matter if the app works great on my device. The best device in the market that you bought with $2,000, the iPhone 19 Pro Max Extra, I don't know what, but it's important that to understand that your application should work well on your user devices, and you should measure your application performance in production for all of your users. We'll go and talk about it in the third part of the talk. So in our case in Wix, we analyzed the user base, and it resulted this spreadsheet, which basically say that 35% of our user base use more than 2 years old device. And it's super important to understand that if we are working on React Native application, because JavaScript engine work different on each device, even if it's first device or old device, it means that the animation won't be slick as you see it in the simulator, and the app may feel much more slower on iPhone 6 and not like running on the simulator or on your personal iPhone X. So let's start. I decided to split my talk to 3 parts. First, we are going to talk about the infrastructure improvements. Do it once and it will improve your application performance all over. The second one is code optimization. It's kind of a cheat sheet to print and put on your desktop in order to remember when you are coding in React Native applications. And the third part is I'm going to talk about tools and monitoring. I'm going to share some tools we develop in Wix, or there are community tools to measure the application performance. So let's start. Let's start from the obvious and talk about Hermes. If for some reason you still do not follow me on Twitter and saw the amazing improvement in Wix application, and you didn't hear about the new JavaScript engine Facebook released last year, you should definitely start using Hermes and stop using JS Core in your Android devices. JavaScript Core is a JavaScript engine which is not optimized for mobile application. On Facebook, they decided to use it only because it's kind of the only one that was exist back then. It doesn't work well on Android, and now we have Hermes. So why to use Hermes? Faster app launches, fast interaction, lower memory consumption. You can see that in our case in Wix, it's kind of improvement of. We saw an startup improvement up to 50% in specific devices. So if you are starting a new React Native application, it's not a question. You should definitely use Hermes. Saying that, it's not easy to migrate your existing big application code base to Hermes for 2 reasons. It doesn't support INTL API yet and missing some ES7 features. So I want to give you 2 tips in case you are struggling with upgrading to Hermes. First, the INTL support. We used an alternative polyfill. You can use Format.js polyfill, or you can use globalized library, which give you most of the features that you have in INTL with all the languages. And keep in mind that Hermes team has a future plan to support INTL. They are currently working it with the community. The second one is proxy. In our case, in the Wix application, we was heavily dependent on proxy. So happy to say that Hermes actually supported, but not officially. You can use Hermes engine version point RC1 and 0.42 RC5 for React Native 63, or 4.2 for React Native 63. And it has proxy support. It's not officially documented, but you can use it. We use it in production. And about other ES6-7 features that is not supported, just remove them from your code. It's worth it. You don't need the object eval and stuff. Just remove it from the code and start using Hermes. So this is about Hermes, a new JavaScript engine. It's worth to mention that Hermes is the officially recommended JavaScript engine by Facebook, but it's not the only one. V8 is also an option and actually experimental by Kudu. V8 is a JavaScript engine by Google, and Kudu is also a speaker here in React Native EU. and he made a POC, and I hope he's going to talk about it in his talk. So keep posted. So let's continue to the second principle. I don't know how many of you watch your bundle file, but I really encourage you to do so. Just run React Native Bundle Visualizer, and you will get a nice HTML file that you can play and found interesting things and didn't know you are using, and library you didn't know that there exist. In our case, in Wix, this is the bundle size. You can see that it's almost 21 megabytes. And when we drill in and analyze the bundle, we found out the biggest library in our code base, 15% of the whole code base is no longer in use. It was a library that came into the bundle because of a small require in the code someone forgot to remove from his library when he stopped using this library. So we need to understand what's going on in the application. In another example, we saw Moment, the date library is pretty big library, Moment and Moment time zone. And the only usage of this library in our case in Wix, it was to calculate a DETS and some other simple operation that can be achieved by kind of a 10 kilobyte library called date.js. So for the second principle, we need to reduce the bundle size, both for iOS and Android. And why? Because it's give us smaller application size and faster startup time. Regarding bundle size, we want to keep it small as possible. Moment is really awesome package, for example, that we talked about. It's easy to use and it's pretty useful and powerful. It was my favorite for handling dates since my very beginning of my web development career, but it's really big. Its core of Moment is only 52 kilobytes, but for some reason it imports all the locale file at once. It's not modularized, so you carry around all around languages locale files in the app. I don't want it, so let's get rid of this kind of library. You can use alternative for Moment. You need to start by analyzing your bundle, use only what you need, remove duplication, try to use modularized packages. You can see in the example of the slide that instead of import all Moment library or all UI React Native UI lib, you should import specific component that you're using. Example, if you're using view, text, and button, and not bring all the library because it's going to be inside your bundle. So this is about reducing bundle size. Let's get back to the bundle size, the bundle file, in our case in Wix. Continue with our investigation. We found out that a big chunk of our code base is actually localization files. Actually kind of 20%. Before React Native can execute JavaScript code, you need to understand that the code must be loaded into the memory and parsed, and we want them to be inside the app. We want all the localization to be in the application. But do we want them to be loaded and parsed at the moment the application is opened from that state? So no. Let's talk about two other optimization we can do for our application. It's run bundle and inline require. Let's talk about run bundle. It's relevant for iOS and in Android if you are not using Hermes yet. Little bit context. React Native is still a JavaScript application. Like in the browser, all the JavaScript and modules have to be bundled, combined, minified before we deploy. You drastically reduce the number of files to one file. It's called bundle.js. The whole procedure stays pretty much the same like in the web. But here's the problem. When you app grows, so does the bundle size. And let's say that React Native apps are usually more than a few kilobytes in size. The heavier your app bundle is, the more time it needs to be fully loaded in the memory, parsed, executed, before even showing you the splash screen. However, the difference in that React Native app is executed in a different environment on your mobile device running iOS and Android rather than on your browser. It allows React Native to be smarter and load the memory only what you need. You can see that where run bundle come into play, it's define new bundling formats that enable on-demand loading of individual app modules, resulting in a smaller user experience. For example, you can see, I try to explain it with this image. In this picture, you can see that all the components in the green side are divided into different groups, which allow me to load the application much faster, because instead of loading the entire bundle, like in the red picture, you can load only the parts that you really need. So basically, I'm not going to drill in and talk about it too much, but we have three formats. We have the plain bundle, we have the indexed RAM bundle, and we have a file RAM bundle. With the standard bundle, not Hermes, if you will have 50 megabyte bundle, all 50 megabyte must be loaded and parsed before any execution of the files. The optimization behind one bundle is that you can load only portion of the 50 megabyte you can actually need for the startup, and progressively load more and more code just when this component are in it. If you have large application, you may want to consider run bundle, run and using inline require that we are going to talk about soon. How to do it? You just need to add for iOS in your command that you want to use run bundle in the bundle command, and the same in the build Gradle in Android. Just add the bundle command. Another interesting thing that you can use preload modules. Now that we have run bundle, this overhead of calling a lot of requires when the application open for the first time. Require actually need to send a message over the bridge when it's encoded a new module as it's not loaded yet. It's basically can impact startup time because where the largest number of require call likely to take place when they upload. So preloaded modules entry in the config can help us to basically to define what is the list of whitelist module that you want to load at once instead of one by one. It should also improve your startup time. That's about run bundle. I will continue about the fourth principle. It's called inline require. So now that we are using run bundle or not, the module are loaded one by one, only when you are asked it in the code. So in order to continue with the optimization, we need to require the modules that are only needed. Inline require is a method configuration, allow you to delay the requirement of a module or a file until the file is actually needed automatically. Let's take a look at the example. In the global require.js, here in the slide, you can see that there is a render function. Render function actually have a very expensive component that is need to be loaded only when the user tap on the button. So why should we require the very expensive component in the global context? Why not only when the user click on the button? So here is an optimization that's the same like inline require do for us automatically. You can see that's very expensive is loaded only when the user press on the button. So it's delayed the requirement of a module or a file until the file is actually needed. It's super important and it's improved the startup time significantly. In our case, it was an improvement of 20% in iOS. So you should definitely use it if you have a large code base. It's super easy. You have a flag that's called inline require in your Metro config.js. You can read more about it in React Native doc performance section. It's all there. I just feel there is not enough attention to it, both for run bundle and inline require, especially for big application. Moreover, beside inline require and run bundle, you should aim to load your code lazily as possible. Inline require is great, but it won't solve all your problem. If you have too much code execution in your application startup, you should consider remove it from there and call it the code later, only when it is necessary. For example, in our case, we saw that we have a lot of dependency injection logic, and when the application load, and most of the code there is not relevant. It can be loaded lazily after or with delay, a few seconds after the application completed to load. So it's super important to understand what's happened when the application load. So that was about inner require and run bundle. Let's continue with 5 principle and the last for this section, offline support. Lack of connectivity is not an error condition. It's super important for understand for our users. Here we are going to talk about 2 principles. Load data from your server only when you need it and save it for future use. And the second one is don't let the user to wait. Because if you have the data in your cache, just show it and update the data afterward. How to do it? If your app requires a large amount of data, it's useful to load only what you need. You should also consider preload or prefetch the data from the server if possible before the user enters to the screen, so that when the data is needed, the user don't have to wait. Another good example is image caching. The app downloads the images every time it launches, basically, which is very much undesired and poor design. So you need to consider cache the images or progressively image load. Consider use network request data, use pull to refresh. There are tons of libraries support image cache and progressive image loading. You can use them. You can also use React Native UILib. It's an open source by Wix that support all this kind of caching, and you have a special component for lazy loading of images or progressive load of image. It's super important because you don't want users to wait for the image to load if you can see only part of the image before. So this is about offline support. Let's continue. So we're done with the first part, infrastructure improvements. Let's continue with the second part, code optimization. So here I want to start by talking about, again, the obvious. You're probably really tired of hearing this, but first DOM performance is one of the biggest features of React. It doesn't mean that you get all of this great performance for free. While React handles a lot of heavy lifting, there are steps that you should definitely consciously take to ensure that your app isn't doing unnecessary work in the render and slowing things down. One of the biggest steps revolves around making such components render method is called only when it absolutely has to. So first, we want to improve our screen visibility and time to interaction. One example is that you can implement your own shoot component update instead of the default one. You can use your own implementation. You can identify wasted renders. We can see in a few minutes how you can do it with the tools that you have. Consider use pure components. Remember to not by default, because pure component is not always the right thing. Making data immutable, don't use something that is don't create function in your render function, and avoiding passing a new reference for the same old data. We can see later how to identify redundant render in the third part of my talk. Super important, it should be in your cheat sheet. First thing to see when you're developing a React Native application. The second one, use loading validation. So basically our perception of time of our users is related to many factors, including but certainly not limited to our age, location, emotions, and our mood at the specific date. The average user perceives that load time, both for web and mobile, are being 50% slower than they actually do. So why not to show the user something and give him the perspective something is happening. Later, when we call in the experience of the user, they remember that the loading time has been 35% slower. They remember that the application is slow even more than it's actually due. By specific research, the average person believes that he spent 9 minutes per day waiting for a slow website and mobile device, mobile application. It's crazy. So how to do it? you can use some visible instant feedback of the application when it waits for the background response, putting something up during the loading process that give the user the perception that it's loading quicker. It can be loader, it can be skeleton, whatever you think it's better. You can see, for example, that in our Wix application we are using something that's called data syncer component, something like automatic pull to refresh when you enter to the page. And you can use this component as well in React Native UILib, which is basically do the network request in the background and render the screen again when the data received from the server. So use loading validation, skeleton, loader, whatever you think it's better. For the third part of this part, use native driver. I hope you heard about it, and I want to show and let you understand how important it is. So React Native allows us to easily create a beautiful animation easily using the animated class. However, unless we specify use native driver specifically when starting our animation, all the work is done on the JavaScript thread. This can cause frame drop in our application. Use native driver fix this by passing all the information about our animation to UI thread when it starts, as you can see in the demo, meaning that the bridge is no longer needed during the course of the animation. In short, use native driver makes animation run much faster, and we can see an example how to do it. Just use use native driver true in your animated timing. The drawback of using use native driver is only support things like transform and opacity. For example, we can't use native driver for an animated value that is used directly on the width style of the view, but you can consider using React Native reanimated, with much better approach than doing animation and transition on the JavaScript side. I wanted to show you an example by spying the bridge with message queue. If you don't know, you can add this piece of code to your development, and it's going to export a lot of console log, all the traffic on the bridge from the native to JavaScript, or from the JavaScript to native, and give you an example of what's actually happened. And if you want to analyze what's happened with the without using native driver, you can see, for example, clicking on a button without use native driver, it's caused a lot of traffic over the bridge, which is redundant because it's not really necessary. We know what is the interpolation that the button should do, and if you want to use a native driver, you can see that we cut the traffic on the bridge to the minimum. Most of the code, most of the logic is going to be on the native side, and the animation needs to work much better. So use native driver. For the next part, React Native is built on top of the abstraction called bridge. That's why you need to consider using libraries that their implementation is in JavaScript. If possible, prefer libraries native implementation over JavaScript implementation. You should aim for a native experience for the users in order to reduce traffic over the bridge. What I'm basically saying that if you need to find the balance between JavaScript and native libraries, think about more traffic following over the bridge means less space for other things. In the GIF here, I'm trying to find kind of a library to be a tab controller for iOS and Android. And for a quick search in Google, I found tons of libraries that's doing the same. They have native implementation, JavaScript implementation, but basically only 2 of them having native implementation for tab bar. And so you should definitely prefer this kind of libraries instead of JavaScript implementation, because JavaScript implementation mostly have a lot of work over the bridge, and it means less space for other things. Let's say you want to load things from the bridge, from the async storage, it should be delayed. Should prefer native. Another option to reduce traffic over the bridge is to use JSI. At 2018, Facebook introduced React Native new architecture, which also explains the three concepts above: JSI, Fabric, Turbo Module. Long story short, the new JavaScript interface, JSI, is another way to pass data between JavaScript and native side. The real benefit of using JSI is that JavaScript and the native side can finally talk to each other, so we not have to serialize the JSON message and send it over the bridge, but talk to each other directly. Having said that, it's not that easy to start and use JSI in your project. As for this time of this talk, JSI is mostly stable, but it still needs some improvement before production ready, and it's not well documented. You can see that there are common libraries in the community, like Reanimated that I mentioned before, that have an alpha version using JSI and Turbo modules, which should bring a massive improvements to the animation. And also React Native Navigation that use JSI and Turbo module in order to have a slick transition between screens. JSI should reduce traffic over the bridge and have much faster interaction. Consider using it. It's a great opportunity to ask Facebook team to help us use JSI with better resources, an example and document. But basically you can start discovering the benefit of JSI and maybe improve your app performance. So until now we're kind of done with the optimization improvement ideas. Let's continue with some tools and monitoring. So we can start by talking about how to catch performance issue. I built a developer happiness scale for understanding how you find a performance issue and when. So it can be in development, in pull request, on QA before you release the version, only in production when you have monitoring, and the third one is when the user complain about a performance issue that the application is super slow. All of my tools that I'm going to show, it's related mostly to the development stage or pull request, when you can build an automated build to run these tools and get result and block the merge button in the pull request. Even if it looks like you want to catch all the issue in development, it's not always possible. Remember what I said, you want to have good experience for the users, not only on your device. I believe that you need to add an APM, application performance monitoring system to your application. There are a lot of companies that provide APM management tools such as New Relic, AppDynamic, Flurry, HockeyUp. It monitors the production performance and give you the understanding what's happening on your user devices. So let's start from the first one that we already familiar with. It's React Native Bundle Visualizer. Install it on your environment and from time to time drill in and understand what's happened inside your bundle. The second one is Flipper. Flipper basically is one of the best tools out there to debug and analyze your React Native application. The real advantage of Flipper is the ability to extend it with your own plugins or download plugin from the community. Here at the bottom you can see an example of a great plugin called Flipper React Native Performance that's analyze your startup performance, split it to smaller parts to better understand what's going on under the hood. Flipper can give you understanding of with device logs, crash report, network requests, understand what you save in your local database, even inspect cache resources and images and understand if the application cache properly. And you can extend Flipper, as I said, with your own plugin. We choose to implement our own internal plugin in Wix for Flipper that's exposing debug mode the state of the logged in user and some other interesting internal objects. In our case, it really helped all the developer install Flipper on their environment and easily understand what's going on when they're working. So you should definitely use Flipper. The second one is React DevTools. If you're not familiar with it, you can use it integrated into Flipper or with Chrome. Just npm install React DevTools. It's great for identify performance bottleneck in your in your application render, identify wasteful render, profile render performance. The real benefit of React DevTools is to analyze render timing. It's worth to mention that currently it doesn't support fully in Hermes, but the great guys from the community and from Facebook are working on solution, so it's going to be available soon. The real benefits of React DevTools, I'm trying to say, it's the flame graph. It's kind of, I call it the render shaming. Flame graph is the default profile view that helps you to visualize the beautiful view, the render tree, and understand how to improve it. You can identify renders take too much and act like a bottleneck. This, for example, is a kind of a view, the main view in Wix that we analyzed before, and we saw that you can see that your list item will render instead of only the top of the list. It's render all the list, so you can improve it. I don't really have enough time, and I hope that Parashuram, also talking in this conference, will cover how to use React DevTools in his talk. What I can definitely say that React DevTools should be always open when you are debugging performance issue on your device. Student Export React Native Perflogger. This library is created by myself to enable production management on your React Native application. In the first phase, based on Parashuram log, I try to measure the duration of the startup time, split it to smaller parts to get duration of the native modules initialization, first time drawing, and time to interaction completed. The benefit of this library is that it's export a huge JSON with all the full reports of what loaded on your startup time, and you should actually report it to the server and to understand what's happening in production. In our case, we report this JSON to the server for smaller percent of our user base, and to visualize all the data with Grafana dashboard. It allows the Google get full picture of how the startup time is split in the user devices. We can filter it by platform, iOS and Android, device type. We can filter by Xiaomi and iPhone 6 and see the difference between the devices. We can even differentiate between app version to identify issue in specific version that we released. Moreover, thanks to this tool, we are able to measure the application time to interaction and other factors in our pull request system in GitHub. So we want to make sure that for each pull request, we didn't hurt the startup time. So we have a step for each pull request that export this kind of measurement between the current master and the pull request and see if there is any degradation. And if there is, we kind of block the pull request to understand what's happened if you accidentally add a code that causes an issue with the startup time. So you can use it. React Native Perflogger is currently support only Android, but iOS support is on the way. Another tool by Wix is Detox Instruments. It's fully open source. Detox Instrument will help you to analyze required tree, CPU and memory usage with a great view, disk activity, network activity. The real benefit of Detox Instrument that you can use your own events. If you want to measure specific interaction, you can add start and end and to use Detox and set visualization. You can investigate and you ASIC storage and bridge, see what's happening over the bridge. Super beneficial. And almost the last one is my favorite one. It's called Why Did You Render? Why Did You Render is a small tiny library that monkey page React itself and tell you when how to avoid render that is redundant. You can see an example that it actually say you have render that's happen more than once because props change, because prop object itself change, but its value is all equal. So it gives you the understand and help you to understand what's happened and why the render is happening. It's notify you about avoidable re-render. You should definitely use it. And I don't have time, so for the last one, console log, because it's why not? We all love to spam our console with a lot of logs, It's super easy to use, start, and understand what's happening in your code. Just remember to remove them in production because it can affect production. So we reached to the end. I hope you got some interesting insight about how to improve your React Native application performance. Always remember that performance does matter and you should invest time to improve your app. It affects your revenue and as a result, lose money. And don't blame it on React Native because it's most of the time our fault. So thank you, it was me. If you have any question, you can send me a message on Twitter and I will try to help. Bye bye.
Thank you, Omri. That's been a really great talk, and I'm always excited to learn more about the optimization and improvements that are being done at a scale at other companies. So let's move on to the next blog of talks, building interfaces. And our first speaker in this blog is going to be Jean, and he is a CTO at BAM, and he is going to talk about a navigation system. But his talk is not going to be just showing you how you can build your app with a navigation. What I really like about this talk, and it makes me very, very curious about it, is that Jean is going to demonstrate a different approach to building apps and different approach to even thinking about navigation systems. So, without further introductions, let's welcome Jean on our virtual React Native EU stage, and let's learn more about how they think about navigations and what does it mean to build an application with navigation by using no navigation.
Hello everyone, my name is Jean Leflore and I'm Deputy CTO at BAM, which is a French mobile app development agency. You can find me on social networks with the handle yleflore on LinkedIn, GitHub, Twitter, and I also write on my personal blog joy2.dev. And today I wanted to talk to you about navigation in React Native. Before we go into technicalities, I wanted to talk to you about the history of navigation itself and the mental model we have associated it with. To understand the way we have come through architecture navigation in applications, we have to talk about the way we locate information in the real world. Let's take a library, for example. In order to find the information you're looking for, you have to first locate the proper shelf in which the books about the subject you are searching for are located. Once the shelf is located, you have to find your book. And when you find your book, if you're looking for a specific information, you also need to search within the book itself for the page you're looking for. As you can see, the way we order information in the physical world is done according to a tree structure, where each level allows us to fine-tune our search. So now let's go on to the digital world. So what happened is that in 1965, while they were working on Multext, one of the early operating systems, P.G. Newman and R.C. Daly published a paper describing what is still known today as the modern file system. As you know, it took inspiration from the physical world by applying the same tree structure that we have seen to information storage. In parallel, we had Ted Nelson, who, while working on Project Xanadu, which was to be the first internet, coined the term link and its usage to navigate between entries. So, when the first web browser was released in 1990 by Tim Berners-Lee, it ended up relying on the same file system structure and used hyperlinks to navigate between them. It also stored the page's history through a navigation stack. So to sum that up, we've got the browser, which displays a page. When we click a link on a page, it changes our navigation stack by asking the server for another page. Now, server side, the router on the server locates the page according to a directory tree and sends it back for display. But even though this model was efficient for reading, the need quickly arose for persistent interactions with the websites themselves. We needed navigation basically to go from stateless to stateful. And according to my opinion, I think three main concepts played a key part in this transition over the years. The first one was the definition of the MVC pattern in 1988. The second one was the proposal of the query string standard starting in 1995. And the last one was the proposal of the cookies standard starting in 1997. And here is how they impacted navigation. Considering those principles, here's what happened if we take into account modern MVC framework. Links were given parameters with the query strings. The server became responsible for storing a user session and persist data thanks to the cookies. Also, with modern server-side frameworks, pages became templates. Now, in order to allow reusing some parts of our code. The next major step in the evolution of navigation came with the rise of the single-page application. While it was conceptualized in 2003, this architecture only really took off with the rise of the AngularJS framework, which was released in 2010. The concept of SPAs provoked a real shift in the way we now architecture navigation. Because there now was a single file, which meant a single path, navigation through the browser stack couldn't work anymore. To solve this issue, SPAs gave a greater role to the JavaScript engine by implementing its own client-side routing. Templates became components, also moving to the client side. They provided the output of what had to be displayed. And the JS router was now unable to use the browser's navigation stack, so one was re-implemented in JavaScript. And well, I know there was an update in the browser's history API, which reversed this trend, but we'll keep it that way for comparative purposes. Finally, the concept of session was also moved to the front end under the guise of what we've come to know as the store. That left the server to be only used for stateless data calls, and that is if you follow the REST protocol strictly. Now, code-wise, if we look at navigation handling with Angular, we can see the remnants of past patterns. First, the navigation is declared as a tree to remain consistent with the URL pattern, and navigating is considered an imperative action from the user. And when we look at React Router for React.js, the exact same can be said. So when switching to React Native, as it emerged from React.js, making it appealing for web developers, is it really surprising that it retained the same navigation principles? But while navigation has proven itself through time, it also came with its own issues, which is why we have to talk a bit about imperative versus declarative. See, alongside React was released the concept of the Flux architecture. It aims at a unidirectional data flow. To illustrate it, I won't go into too many details. A state is given to a component by our store to display its data. And the component can send an action to our store to receive an updated state. But if you remember, we have grown accustomed to navigation being handled by the browser, with our stack handled by a navigation library. And if you isolate its essence, it turns out that in accord to the Flux architecture, our display is handled by our components. Navigating itself is actually an action sent to our stack, and the stack is actually also a navigation store, resulting in a navigation state. So now we have our entire navigation on a store we don't fully control because it's handled by an external library. And according to my own opinion, it causes a couple of issues. The first issue is having a page name as a parameter, because we're so used to routing with URLs. It is essentially the same as calling a show method directly on our destination page instance. And I think this is a well-hidden imperative call and an anti-pattern to the Flux architecture. And it also breaks the principle of separation of concern, as a page has to know what its next page is. For example, if we navigate to a profile page after login, our login page itself becomes interconnected with the profile page logic-wise. And if you decide on creating a navigation service to leave your component outside of this business logic, it only worsens things by making navigation a side effect of your store actions. And this service becomes a default when you start listening to events provided by your phone. Now, my second issue with navigation is that it's everywhere in your code, basically. Here's an example of a simple app that I built consisting of only 2 pages. The first page is logging in with Dropbox. And then, once you've logged in, you select a folder. Here is a high-level diagram of the app without navigation. I find it simple enough, and you can clearly see the Flux architecture. Now look at what happens when we add navigation. It becomes interconnected with every part of our app. But I have one last gripe with navigation, and it's the fact that I think you don't actually need it. See, if we come back to the initial definition of navigation, it's the action of going from one page to another page based on a user action. But if you take our app navigation architecture, we don't have pages anymore, and we don't have a browser requiring a URL or handling our navigation stack. So the concept of navigation itself, as we understand it, is only a mental model linked to our past as web developers. And React Native itself has shown us that with its own components that we can write navigation in other ways. Let's take an example. We have the model, which is one of the core components of React Native, and it uses a purely declarative way of handling itself and its transitions. So my question is, why can't our pages do the same? Also, removing navigation is not only a developer concern, but has also become a designer one, as we'll see with the concept of no-nav. The term no-nav was coined by Caroline Bénard, one of my colleagues who's head of design at BAM. About a year ago, she came up with the concept of no-nav, which she wrote about in an article, I think it was in early January. It states that navigation should be your concern number 2 after the concept of your product, because a bad navigation is a break for adoption and decreases the product perceived value. With mobiles, we have less space to display the same level of information, which of course led to requiring more navigation to reach the desired feature. Yet, because of mobility and the reduction in attention spans, our users actually want the opposite and need faster access to features. So, is it not surprising that most redesigns initiatives aim to reduce navigation? Let's take a look at the redesign of Messenger. It went from 2 tab bars with a whopping total of 8 tabs to a single one with only 3 tabs. And if you take Uber, basically they mapped their user journey. So you search for a vehicle, you wait for it, you have the ride, and then you rate your ride. By using this user journey, they managed to produce not 1, but 4 distinct home pages in order to avoid any navigation at all. And the beauty in this concept, I think, is that in the user's perspective, if you use the context to show them what they need, when they need it, to them it feels like magic. And doing this has even been simplified thanks to the information given out by the mobile itself. We have access to tools such as position, Bluetooth, network status, push notifications, deep linking, sharing, and many more. And all of them give us even more context, often outside of any user's interactions, and allow us to deduce the user state without navigating. So, what can we do as developers to achieve no-nav in React Native? Well, thanks to another of my colleagues, we have a solution. Thomas Pucci, a VP of Engineering at BAM, published a library called React No-Nav, which handles navigation in a purely declarative way. What it does is only handle transitions using 2 main components: a canal to handle transitions between children, and a screen to declare a component's own display state. If you go into its configuration, it's the transition itself. And where I believe this library shines is that because it only handles transitions, that allows us to take back control of navigation through a single source of truth that we can manage ourselves. But we're not done yet. See, we took back control, but because the current state is in our own store, we now have to compute a new state upon receiving a navigation action. For example, if we receive a login event and our previous page was the home page, then we simply, in our new state, go back to the home page. But if our previous page was the order page, then the current page should become the confirm page. And let's say we want to compute if the confirm page should be displayed. Well, we might have to take into account other state values. For example, if our network is down, we might not want to redirect the user to a confirmation page. The way we translate it into code is by nesting if conditions, which will become messy and bug-prone whenever we're scaling or writing down complex user journeys. So this is where Xstate comes into play. Xstate is a fully featured state machine library for JavaScript, which was created by David Khorshid, and which adheres to the W3C state chart specs. Here is a simplified explanation of the core blocks of a state machine. Well, you have the main blocks are the states representing our system at a specific point in time. When receiving events, we transition between states. We also have a context to share data between states. And services, which are side processes controlled by the machine that can send events to it. Finally, there are actions, which are side effects. They come under many forms and we won't go through all of them. But our main one are assign actions, which allows us to update our state, and classic actions, where we don't listen for any return event or value. The core difference with traditional state containers, such as Redux, is that those libraries only offer a subset of X8's tools. If we take Redux, for example, the context is equivalent to the store, our action to the reducer, and the event to actions. So the entirety of Redux can be summed up by only 3 of the tools available in X8. And the extra layer of tools allows us to streamline our developer experience greatly. Services are a native way of handling all of our phone's context, as they translate callbacks into events. And fire and forget actions are very useful to handle things such as logging or analytics. Finally, states, events, and transitions allow us to map our business logic without having to rely on nested ifs conditions. Here is how you declare a machine. You give your machine an ID, an initial state, and context. You declare your available states, the events which can be handled by each state, and the transition which can be selected according to a condition. You can also start services to listen to external events and trigger side actions in reaction to an event. And all of that can be previewed with a useful online state machine visualizer, which resembles much more what we would draw on a board than a long list of conditions. And if you remember the Dropbox app, because state machine allow nesting and parallelization, I was able to split my navigation architecture. And this allowed me to isolate completely what we considered as pages into their own black box isolated modules, which meant that I could essentially reuse my pick folder or logging page anywhere in any other app. So, to sum everything up, we have mobile navigation, which is a mental model that came from our past. Our mobile users want to avoid it. To do that, we need to use as much context as we can, but context gets messy because of imperative navigation. And we also need to control it ourselves, which means that it is complex to write down because of nested if condition. So what we do is that we use React NoNav to handle transitions based on declarative props, and we use X8 to handle our context and map complex user journeys. And this is why I really welcome you to try out taking back control of your own navigation with X8 and NoNav. Thank you so much for listening. If you want to find out more, you can head out to joy2.dev/x8nonav, where you'll find the slides with my notes, links and references, and of course an open source example of an app using X8 and NoNav that you can play with and deploy. Thanks again for tuning in, and I would be delighted to talk to you on social platforms to discuss this talk. Bye!
Thank you, Jean. Really exciting talk. Can't wait to test that approach with my next React Native application. So let's move on to our next speaker, Alexandra, and she will be talking about animations. Now, we all know that animations are an important part of every mobile application. It is what defines the user experience of our app and can increase the conversion and user engagement by many times if it's done right. And now Alexandra is going to talk today about how we can build animations in an easy way, and that animations are not really something that we should be afraid of. Before we move on, I just wanted to let you know that this is her first talk on a public event like that, and I'm really excited that React Native View can be the place where she makes her first appearance. So, Let's give her a warm virtual welcome on our virtual stage, and I'm hoping that she will receive that virtual welcome and that virtual applause during some virtual transfer protocol. And yeah, let's move on to her talk.
Hello everyone, I'm very happy to be here. I'm also a little bit nervous because this is the first time that I'm giving a talk, but I hope everything will go smoothly. The title of my talk is React Native Apps Can Be Beautiful, an Animation Showcase. First of all, let me introduce myself. My name is Alex, I'm Polish, I live in Gdynia, and I've been a front-end developer for about 7 years. I've been working at Format for over 2 years now. I work mostly with React.js, and let me tell you a little bit about Format. It's a portfolio website builder. It's seriously one of the best website builders out there, and I would know, I wrote some of it. But anyway, I really recommend it. It's a great website. It's also a great workplace. My talk will be divided into 4 parts. First of all, we'll do a small introduction into animations. I will try to show you that animations on the web are very different ideologically from animations in React Native apps. Then we will go through some real-world examples of apps that are out there. Next, we will dive into some solutions and strategies which can be used to add animations to your own apps. And if you manage to stay with me until the end, I will introduce you to a very cute digital dog called Pushek. So let's dive right in with the introduction. Why should you care about animations in your apps? A lot of people who work with React Native have a web development background. They have some preconceptions about animations. Animations on the web are considered to be something unnecessary, something that slows down the user website, something that doesn't add anything to the content of the website. It just makes it pretty, and it's sort of an afterthought. Web developers also have to consider the fact that the user may be on a very slow internet connection, so the animations just seem like a lot of fluff that may be blocking the user from getting to your content. However, we need to look at React Native apps with fresh eyes. Apps are not websites. Users on website users have very different expectations than app users. Whenever someone uses a website, pretty much the only expectation they have is that the website will scroll. It can be just plain text. I mean, we've all been to Wikipedia, right? It's just plain text. It scrolls, it works, it's just fine. However, when we use apps, we have much higher expectations. We are used to a lot of features that we use on our phones, and we expect those features to work across all apps. Those features are gestures, loading states, pull to refresh, swiping, and a host of others. And I mentioned bandwidth before with websites. This is something we are not concerned with when we talk about animating a React Native app. Once the user downloaded your app, the animations will run no matter what their internet connection is. So we can go crazy. And seriously, we need to break out of the old patterns, because it's not enough to just slap together a view with a bottom navigation and just say we're done. We need to do more. As far as animations in a React Native app are concerned, I believe we can distinguish 3 contexts: gestures, motions, and micro interactions. Gestures are pretty self-explanatory. That's everything that happens when the user swipes or half swipes and the content bounces back. Maybe they're scrolling faster, panning, or pinching the content. Motion is a very general term for animation, for everything that moves around on the screen. And microinteractions are subtle element animations that appear usually in response to a user action. I feel that the most famous microinteraction is the ripple effect on the button in Material Design. That's the small grayish ripple that appears on those Material Design buttons when you click them. Let's talk a little bit about the goal of motion and interactions in apps. This slide was informed mostly by the Material Design documentation and a UX design article. As far as Material Design is concerned, even if you don't like the look of Material Design or you don't like Google as a company, I still recommend reading through the documentation. It's a very high-level view, and it's very useful to keep in mind the guides and the rules that they set forward. I listed out 5 goals of motion and interactions in apps. The first one is that motion provides timely feedback and indicates the status of user actions. This is pretty much what I mentioned before with the ripple effect. When a user touches or clicks a button, they want to know that they did click it. They want to know that they didn't accidentally touch another element, or maybe they will start rage clicking it 1,000 times and you'll end up with a broken application. If you use this subtle ripple effect on your button, the user will immediately be informed that they did correctly click the button, and all they have to do now is sit back, relax, and wait for the result of their action. The second goal of motion interaction apps is that motion celebrates moments in user journeys and it adds character to common interactions. Now, this is something most commonly used in onboarding flows, for example, where we have pretty places where the brand can show off their beautifulness, pretty much. We do not want our React Native apps to look like a block of text or like an Excel sheet. We want them to be beautiful, right? And animations are the way to go. The third goal of motion interactions in apps is that motion helps users understand how to perform actions. You can think of that in, for example, if you click a buy button and you see the image of the product that you just bought move up to the image of the cart, for example, that draws your attention to the cart and helps you understand how to go to your cart and finish your shopping. And the last goal of motion interactions in apps is that motion helps orient users by showing how elements in a transition are related. The best example would be on a category page in an e-commerce app. When a user touches actually a product image, the product image would, let's say the image will move slightly up and the product details appear below the image. The user will understand perfectly what happened, and they will be nicely oriented compared to a situation if they click the image and the whole screen goes blank and then another screen appears with all the information. They may feel a little bit lost. What I want to convince you of here is that we need to push our apps from just usable to delightful. This is a quote from a great article by Tristan Plank that I highly recommend. Tristan explains in much greater detail microinteractions and motion and how our apps can really go to the next level and be really great and not just okay-ish. Okay, so it's time to dive into the real world. Let's start with the Uber Eats app. The Uber Eats app uses React Native, and it actually uses such great animations that there's a Mashable article written about those delightful animations. Imagine if that happened to your app. It's great that not only is your app useful, it's so beautiful that it warrants a whole article about how beautiful it is. The second real life world example that I want to show today is the Wix app. Wix has a very nice animated onboarding screen, and they use subtle animations and cards, and when we get to the navigation, they use a very natively looking nice animation with a round button that appears only if you scroll up to the top. That's something that helps orient the user, get them where you want them to be, and have a blast using your app. There's a big chance you've all heard about Uber Eats and Wix, so let's move on to something that you may be not familiar with. It's an app called Shine. It's a self-care app. It's written in React Native, and just look at that beautiful splash screen. I love it. I love how the yellow wave shows up. It just it's so pretty, and it's written in React Native. The rest of the app is very nicely animated as well. There's a bunch of appearing, disappearing, bouncing elements to it. It plays together very well with the idea of self-care and being positive and leading the very best possible life. This app actually received a bunch of awards. It received the Best of 2018 award in the App Store, as well as 2019 Google Play Award in the Standout Wellbeing App category. That's a mouthful. This app has an average rating of 4.7 in the App Store. So this app is an absolute proof that React Native apps can be beautiful and usable at the same time. At this moment, I would also like to mention that the GIF you're seeing on this slide is a screen recording from my pretty crappy phone, and still works very smoothly. There's no glitching, pretty much no problem at all, even though my phone is really slow. My phone can actually freeze when I'm trying to take pictures. It freezes on camera, and it doesn't freeze on this app, so way to go, Shine. The next real life example that I want to show you is the SoundCloud Pulse app. That's a difficult word. This is an app for SoundCloud creators. I'm not a SoundCloud creator, so I only could go through the onboarding screen. But still, on the onboarding screen, we already see those very nice subtle animations that make this app pop. This is really a great example of how a small animation can make a big difference. SoundCloud also wrote a couple of blog posts about their experience with React Native. It's a very good read. They are very honest with their experience. They don't sugarcoat it. They don't say they are totally in love with it. They talk about the caveats. But the bottom line is they did have a great experience using it, and they are planning on using React Native in more places at SoundCloud. The next app I want to show you is Shop by Shopify. Shopify is a company which seems to be pretty in love with React Native. They are very vocal about their involvement and their investment in React Native. They do articles, they do Medium posts, Medium articles about their experiences. And take a look at this app. You can see right away the subtle animation of the small arrow that goes up to the button. on the top of the screen, you really want to click that button, right? You just want to get right in there and use this app when you see this delightful animation. The next example is an app for KFC. This app starts out with a full screen video. I mean, this is just incredibly engaging. You start the app and it's not just a splash screen, it's actually a piece of chicken, and I get hungry just looking at it. Once the video slides up, there's a very cute animation of Colonel Sanders asking you your name. It's a very nice experience, and it's really looking delicious. I like to say that there is no point in reinventing the wheel, right? So I just showed you a few examples of real apps that use very beautiful animations, and why don't we just inspire ourselves with what they did? We do not need to invent a new way of doing what they did. They already did it. Let's see how they did it. If you want to see how what libraries were used in an app that you feel is a good example, that is something that inspires you, you can actually look into their source code and find out how they did what they did. First of all, you need to choose your app. Let's say you choose your KFC app. Then you need to find the APK file for this app. There's a bunch of websites that offer free download of APK files. A few of them even have a release date, so you can be sure that you're downloading the latest APK file. Once you've downloaded the APK file, you can use the Android Studio app to analyze the APK file you just downloaded. When you open up Android Studio, there's an option. Instead of opening an app, you can click Profile or Debug APK. You click that and then you choose the APK file you just downloaded from the internet, and Android Studio will show you a bunch of files, and within those files you will see classes.dex. Classes.dex is a file which will include all the external libraries that the given APK is using. You can look through the names of the libraries used, and then you can research them. You can see if they're open source or not, if they fit your needs or not. And then it's okay to use whatever everybody else is using. You can simply use the same library. Why not? And then you can actually brag about using the same library as Uber Eats or KFC. That's cool too. I've been snooping around the apps that I showed you earlier, and I can tell you that a lot of them use Airbnb Lottie. I know there has been a little bit of drama with Airbnb leaving the React Native world. They said they are moving away from it, but they did leave behind this Lottie library. I will get back to it in a second. The second library I would like to, animation library I would like to recommend is Reanimated. There's also a library called Pop Motion Pose, which I haven't personally used, but the documentation looks incredibly great. And the fourth library that I would like to recommend is Fluid Transitions. Let's get into some details. Airbnb Lottie is something that is a library that works with a plugin for After Effects. So what happens is that you have your designer create your animations in After Effects, or designer, or you yourself maybe, I don't know. Once you have your animations ready in After Effects, you can export them into JSON with a plugin called BodyMovin. And when you have them exported with JSON, you can use them in your React Native or your native app thanks to this library, Airbnb Lottie. And the effects are very beautiful. That's a library that I saw this library listed in the APK file for Uber Eats, and I'm pretty sure that's what they used for their delightful cooking animations. The second library animation library I would like to talk about is Reanimated. This is an animation library which kind of has a steep learning curve. You do need to invest some time in understanding how it works, how to best use it, but this is a library concentrated on performance. And once you do get to know it, you have a lot to win from using it. I would also like to talk to you a little bit about the Fluid Transitions library. Fluid Transitions is something that can really make a big difference in an app. Orient the user, let them know what they're doing, and make the app beautiful. The creator of the Fluid Transitions library did a JS challenge, and in that JS challenge he created the app that you can see in the GIF on the slide. Now, I'm very impressed with what he achieved. This is something that he did with React Native and his own library, and it looks incredibly great. It looks like something that has been produced by a huge team at Nike, right? This is just one guy, and he did that in React Native. I would like to introduce you to a very cute digital dog that I named Pushek. Here's how he came to be. First, there was a dribble shot created somewhere in 2015, and then a Codrops article, which inspired me in turn to create a React Native app with an animated dog using only React Native Animated API. I would like to say that people responsible for the dribble shot, the guy, actually there's just one person that created this dribble shot. He's responsible for the look of this dog, and this dog is so cute, right? Then the person who wrote the Codrops article, they solved so many issues on how to have this dog animate the way it is animated. He's animated in CSS only. And I feel that those two people really did the bulk of the work. I only drew from what they did. A fun example is the tail. I don't know if any of you would have an idea how to animate a tail that would kind of go up and down like this. You actually have to you have to create tiny tail elements and nest them one inside of the other, and that's why they kind of hinge on one another, and the tail moves like a tail. That's an incredible idea. That's an incredible way to solve a simple problem. Not as simple, that's an incredible idea to solve a difficult problem. It's a simple solution to a complex problem. So while I was working on Pushek, I repeated myself that math is my friend, and I would like, as much as I would like to look like the lady on the image, more often than that I looked like this, because you do have to do a lot of calculations in your head, kind of think in an abstract way, trying to get all of those elements moving the way you want them to move around. Luckily, I could be inspired by the Codrops article, and I seriously drew a lot of solutions from them. But some solutions were not applicable from the web to the React Native app. The biggest one was actually the size of the dog, kind of like the placement of the dog, I would say. So I started out with writing my dog. I had my emulator, my iOS emulator, and I just went ahead and I started drawing a dog with percentages. Moved this element 30% up from the bottom, this one 30% from the left, rotated, and it's all fine and it's looking good, right? But then I fired up another emulator with a phone that had a significantly wider screen, and poof, the whole dog just went haywire. because the ratio of the screen was different, and I didn't want to use a block with predefined pixel values for the dog, because if I did that to box him in, then on some screens he would seem smaller, or maybe he would be not placed exactly in the middle. And seriously, even if he was smaller, I want him to look exactly, take up the exact amount of screen on all mobile devices. And that's why I invented my relative width and relative height elements. I decided that I need one unit that will be a measuring stick for my dog. So I created full relative width, which is 80% of the width of the device, and full relative height, which is 1.5 of the widths of the device. I use those measuring sticks to put all my absolutely positioned elements on the dog, and they end up exactly where I want them to be, no matter if the screen is kind of on the wider side, or if it's a smaller, or if it's not as wide. In order to style Pushek, I use CSS and JS. I kind of I create separate files for CSS, since there is a lot of it. And I added my animations in the components. They are a lot, I would say. There's a lot of code to create this small dog. If you want to read through it, the repo is public. Go ahead and check it out, and let me know what you think about it. So what's next for Pushek? I would like for this app to be much more interesting than just an animated dog. I actually invented this app as a weather app. So I started out with a dog, and I spent a lot of time on the dog, but I would like to display the weather in this app. And I would like to not only display the temperature, I would also like to show animations of the weather, like the sun, clouds, the rain, maybe snow. I would also like to give the users a chance to choose their own animal. So I like to add other animals. I know that Sarah Drasner created a farting rhino, and I would love to be able to add him to this app. And the top of the top for me would be to integrate Google Actions for this app. So my dream is that my 5-year-old kid will be able to pick up the phone and say, okay, Google, ask Pushek about the weather, and that's when Pushek will tell him about the weather. And I'm hoping to be able to achieve that, and maybe I will. Maybe that will be a topic for our next talk in the future. Well, never know. You never know. That's it for my presentation. I would like to thank you all for listening. I want to credit SlidesGo. I used their slides template for this presentation, and it was a great experience. My DMs on Twitter are open if you want to ask me any questions. Go ahead and check out my repos, and let's go ahead and create some beautiful apps.
Thank you, Alexandra. That's been really great talk. I'm already convinced that building animations is easy, and I will use them in my application for sure, everywhere I can. Now, that wraps it up. Let's move on to the lunch break. I already got my meal in this box. And so before we move on and before we all get started on eating, I just wanted to remind you that the agenda of the conference is on the React Native EU website. The link is here. And again, as always, don't forget to tweet about the conference that we are streaming live. And if you have any questions, just go to the Discord channel, leave them, and we will answer them during the panel that we will stream after the conference. So, enjoy your meal and see you after the lunch break. This conference is brought to you by ColdStack, the React and React Native development experts. Meet us at coldstack.com.
Hello.
Wake up in Wrocław? Get up and get at 'em. React Native EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. We'll see you next year. Calling all builders and tinkers, the doers and linkers, the ones who create it from scratch and the ones who code a clean patch. The code ninjas, the toolers, the thinkers, and don't forget the seasoned drinkers. Your open source lovers, your time tracking haters, the JavaScript junkies, and the wild bug wranglers. Your community is here and it's waiting for you. It's the first of its kind and it's called React Native EU. Core contributors and insights and networking and knowledge, all for React Native, it's in our language. Find us in Wrocław, Wrocław. Difficult to pronounce it. Your good vibes are here, go on and announce it.
Hey, welcome back after the break. I hope that you enjoyed your meal. And let's continue with the building interfaces block because we got a lot of talks today and tomorrow, so sorry if I'm rushing, but I'm pretty sure that you are in here for talks, not just me talking, so I'll make my introductions real quick. So our next speaker in this block is Akshat from McKinsey & Company, and today he's going to talk about building AR and VR apps with React Native. Now, if you're like me, you know AR and VR as buzzwords from the community, and everybody's now building AR and VR applications today, but Akshat today is going to tell us how we can make that easy by showing us some practical examples. So something that's really great because practical examples are always better than theory, right? So let's move on and let's welcome Akshat on a React Native EU virtual stage and learn about building AR and VR apps in an easy way.
Hey, this is Akshat Paul, and the topic for this presentation is Let's Go 3D with React Native. You must have guessed it from the title that we are going to talk about augmented reality, virtual reality, and how to build such type of apps using React Native. So let's get started. I am Akshat Paul. I'm an author, developer, building all type of applications, mobile apps, web apps, DevOps sometimes. I also have a fancy pant designation at my place of work, which is digital expert. My Twitter handle is Paul Akshat. Please feel free to follow me. And you can also visit akshitpaul.com. That is where you can find all my books, my publications, various talks and discussions I've been part of. And that's the best place to contact me if you want to discuss any new exciting problem, or maybe just want to pair for a React Native application you are facing any issue with. So as I mentioned, I'm author and technical reviewer for a few books. The topic ranges from Ruby to React, React Native. The most recent ones are the Ruby Workshop and React Native for Mobile Development, second edition. So let's get started with our presentation. So the agenda for this talk is a quick introduction about AR, VR, MR, how to build apps for this genre of applications, how can we implement augmented reality, virtual reality using React Native, and of course learn with example. I'll show you a demo and also share the source code for that via GitHub repo, and you can build upon it. The takeaways I want you to take by end of this talk is that you have fairly good idea about such genre of applications and are very comfortable to start building this application immediately after my talk. So let's dive into this. So first thing, what is augmented reality, virtual reality, and mixed reality? Augmented reality, virtual reality, and mixed reality are in total called as immersive technologies, where virtual reality is fully artificial environment in which the user gets into a digital world, essentially teleporting into a different digital universe. While augmented reality is like an overlay over our real world. That's it. And mixed reality, also known as augmented reality 2.0, where the user is just does not see the overlay over the real world, but also can interact with these digital objects. The reason they are combined called as immersive technology is because the user is immersing into this digital environment and does not know the difference between the real world and this digital world. Another term quite often used for immersive technologies, which is VR, AR, MR, is called extended reality, where X is a variable. And extended reality is a term used for all real and virtual environments combined together, where human and machine interactions happen via any computer technology, where X represents any current or future computer technologies, because every other month or every other year, more and more variables, forms, and gears are coming out. So it can be beyond just virtual and augmented reality, and more types of experiences could come in future. So X is that variable. So what is a virtual reality? Virtual reality is the use of computer technology to create simulated environment. Unlike traditional user interfaces like graphical user interface or mouse interaction with a plain surface, with virtual reality, the user actually gets inside the virtual world. To experience VR, one of the most economical devices, Google Cardbox. If you want more computing power, there is Oculus Rift, Samsung Gear, and it's used quite often in gaming and education applications. But VR as an idea is not something new. It's been here for decades now. One of the first VR gadget we can say was Sensorama, released in 1962 by Morton Healing. Sensorama was considered as one of the earliest form of virtual reality, and it was a mechanical device, but it was also a crazy device. It had a color display, fans, odor emitters, stereo sound systems, and also a chair which would have motion. It was like combining the user in a scene along with the experience of an arcade game. Besides Sensorama, there was also Sword of Damocles, another VR gadget which was patented in 1960 and released in 1968, invented by Ivan Sutherland. This was a very basic, rudimentary VR experience where the user could interact, move around in simple wireframe room. Few popular virtual reality apps you can try right away are Netflix VR, and YouTube VR, which converts YouTube videos into a virtual reality experience. There is Google Street View. There is also another application called Expedition VR, which is quite an interesting application. It allows you to have expeditions of Mount Everest and underwater world, but make sure you do not have issue of motion sickness with VR headset, like sometimes I have. So I prefer AR apps more than VR application. Next, let's learn about what is augmented reality. Augmented reality is a real-time use of information in the form of text, graphics, audio, and other virtual and digital objects which are integrated with real-world objects. Most common AR device is our smartphone and tablets. For higher computing power, there are devices like HoloLens and Magic Leap 1 headset. Augmented reality is already here. If we see, there are a lot of application and lot of industries whose key feature, the killer feature for them, is their AR capability. If you look at photo and video apps like Snapchat, their filters are example of AR. Games like Pokemon Go, which was my first experience to AR. Then Google Lens, which allows you to search what you see. So it significantly improves the search time and experience. And now that we know enough about AR and VR apps, let's now learn how to build AR VR mobile applications. To build an AR application in iOS, the underlying platform is ARKit, and to build it on Android, there is AR Core. Fundamentally, both these platforms are quite similar. Before we start programming on a AR application, there are few principles which we must have a good understanding of. Essentially, there are three things, which is tracking, scene understanding, and rendering. Let's take them one by one. Tracking. Tracking has something called a tracker, which is a specific pattern which we have programmed, and once this pattern is recognized, it's constantly tracked. Like in this example, there's a person's body, like, or a facial recognition patterns, like a nose, eyes, ears, and once it's recognized, it's constantly getting tracked, and we can put filters on it. Let's take another example of these two videos you can see on your screen. Here, whenever the AR application switches on the camera, it tries to understand the world around it, and the moment it finds the pattern, in this case that the lamp, the program consistently tracks it. So tracking by definition is a way to get your device relative position in its physical environment as you are moving your device around in a space. And next is scene understanding. Scene understanding is detecting plane, hit testing to set the anchor points. This detecting of plane is basically understanding if there is a flat surface, whether it's a table or a floor, where we can then place our digital object. Else your digital object will be hanging in the air. Then it's light estimation, which means the light detection of the space we are in. The example here is that imagine you're in a scene which has a very dim light, and you place your digital article which is very bright, so it will not add up. So if you have this information about light estimation, you can put in proper shadows and correct lighting for that digital object so that it blends into the scene. Next is rendering, which can be done using SpriteKit, SceneKit, or Metal. SpriteKit, SceneKit, and Metal both come out of box from with ARKit, where SpriteKit is used for 2D objects, SceneKit is used for 3D objects, and Metal is more powerful and custom rendering engine if you require it. The other options are Unity and Unreal, which are very, very powerful rendering engines, especially for heavy duty games, and very good option. For Unity, you need to program in C#, and for Unreal, you need to program in C++. So not a very good option for people like us. Then how do we implement AR VR apps with React Native? of course, there must be some solution because we all are in React Native conference, and there is one which is called Vero Media or Vero React, which is a React-based development platform which allows us to leverage APIs from ARKit, ARCore, Daydream, Gear VR. Some key features of Vero are that it's cross-platform, which means write once, run anywhere, across all mobile AR like ARKit, ARCore, and VR support for iOS, Android, Gear VR, Daydream. It's a React-based framework, React Native-based framework, which makes it very easy for developers like us who work on React Native to get started building a AR or VR application. It has a very powerful renderer which supports real-time lighting, physics, particles that helps us create stunning scenes in our application. It also, it's one of its key feature is rapid iteration, that it supports hot reloading, which means Vero actually comes with something called a test bed, which is a companion application called Vero Media, which has a feature called test bed, and which supports hot reloading, and it immediately refreshes whatever you have programmed. So no need to wait for any compilation. It's just like refreshing a browser. So it's fairly quick to develop applications and test them out immediately. The installation is very simple. Just install its npm package, React Vero CLI. It's similar. The CLI is similar to React Native CLI. It also comes with a companion application, which is Vero Media, which you can download from App Store or Play Store. And what it does is that it uses ngrok in order to show your local development, and which supports hot reloading. So the moment you develop anything on your local, you save it, you can immediately see the result on Vero Media test bed. To generate this to Vero project, it's pretty simple. One command, React Vero init and project name, and then you can start building on this skeleton application. I have done that already, and now I'll be building an AR application on this this empty skeleton which I have created. So let's get started with our demo application, and let's see what all we are going to learn in this demo application. We're going to know about Scene Navigator. Then we are going to detect a plane, which is a flat surface in the real world. And then we are going to place an object on this plane, which is the flat surface we are going to find using our camera. So Scene Navigator is the entry point of any Vero application. Vero AR Scene Navigator and Vero VR Scene Navigator are entry point for AR application and VR application respectively. If you see here, we are going to present our initial scene, which is AR welcome scene, to Vero AR Scene Navigator component. We'll write all our code in AR welcome scene.js. In AR welcome scene.js, we have Vero AR Scene. Earlier we had Vero AR Scene Navigator. Now we have Vero AR Scene component, and this is the top level component. So any Vero application, this has to be a top level. The rest of the components are the children of Vero AR Scene. Here you can see that we are also using a prop on tracking updated. This is a callback prop, and you'll see why we are using it. Then we have a very basic component, which is a text component. Our text where we'll put our welcome text. And below that you can see the styles, absolutely similar to styling of any React component. Here you can see that we have placed something called position and scale, something new you will find. Now the position is X, Y, and Z. We have put X0, Y0, and Z -1. With -1, the object, this text object will stay in front of the viewer. This is the reason why I put it as -1. So let's So the next part, which is on tracking updated prop. What was the purpose of this callback prop? So when our application starts, we will see our AR app is getting loaded. That is the initial text message we are going to place. But as the state of our application changes and it becomes tracking normal, as you can see on the screen, we will change the text to welcome to React Native EU. RNEU. So let's load this application and we'll know more about it. To load our application, to take a look at our application, we have to do npm start and also make sure that the ngrok is on. Sometimes it has error, so you can start ngrok manually. But once done, you simply have to open Vero Media application, go to testbed, enter your ngrok URL, which is unique to you. The one you saw on screen is the one when I created this demo. It won't work now. First time when you load the application using Vero testbed, it takes longer time than usually. Of course, when we hot reload, it's pretty quick. It's not instant, but it's very quick, as we will see in the next section. And this, it's 100%. And you can see this is the initial text which is still there, and as the state changes, the text changes. You can also see a React image which is converted into a grid box and is rotating. This is a very basic animation which we have put. So that was easy. Now let's move to the part 2 of our demo, which is plane selector. So in any AR application, the device camera shows us on-screen view of the physical world. Virtual objects are then superimposed on this view, that is like a table or a floor. For this purpose, Vero has an out-of-box component called Vero Plane Selector. So we can simply, in order to test it out, we can simply place this component in our application, maybe just below the text we have created. It doesn't matter. It will start detecting any plane once the application starts. Once the camera start working, it starts locating if there is any flat surface, whether it's a table or a floor. Let's try it out. And once we save it, the hot reloads immediately loads our application. And 100%, and once hot reloading is complete, we can see that first we see the text, and if we move our camera to a floor, we can see the gray part that Vero React is able to detect the plane. We can see the text. It even detects the plane on the table floor. And anything which is flat surface, whether it's a book cover or anything which is a flat surface, it will consider it as a plane. Now let's place an object on this plane. What I've done here is that I've simply used a Vero box component and used another image. So Vero box component is the same component which I've also used for the React logo. What it does is that it converts, if I pass an image to it, it converts any image into a 3D box shape. So basically all the sides have the same image. It repeats itself and creates a 3D object in itself. So let's now reload our application. And what will happen is that only when we click on the gray plane which gets detected, the 3D object will be dropped on that location. So once our application starts, we can see the standard text, and now the plane. Sometimes we have to move the application around a bit in order to allow it to detect the plane. Here the plane is detected, and now when we click anywhere in the plane, our Buzz Lightyear image is dropped there in a box shape. So the initial text, the React logo stays where it is. Wherever the Buzz Lightyear image is dropped, it will stay in the same position, and we can move around our camera as much we want, but all these three things will stay static where they are, as if they are part of this environment. So where do we get these 3D objects, 3D models or scenes? There are a lot of places, some free, some paid. Unity Store, Unreal Marketplace are great places to find and explore these 3D objects and models. There is Mixamo where you can actually get it built. Then there is Sketchfab, which has a lot of free stuff. You can try it out. And now we are almost drawing close to our talk. And of course, one question you must be would be buzzing in your mind, that when should I use Vero and why should I use Vero? Why I've tried to answer it as Vero being React Native based framework. It's an organic choice for any React Native developer to try it out. When should you use it? Except if you have a very high graphic intensive application using physics engine, or maybe very heavy duty game. Beside that, you can use it everywhere, especially in applications which are text based or information based. It's very, very helpful. Even for building applications for events, big conferences, which direction is what, you can very quickly build such applications with Vero. So the possibilities are quite a lot. Of course, whenever you learn something new, you try something new, it does take a little bit of time to get hold of it properly. So do give it a chance, and I would like to end this talk on this image, which I often refer to a lot of developers when they try something new. If you're trying something new and it's not working out, it's a bit clunky, before blaming the language or framework, we must always revisit our code. So on this note, that's a wrap. Thank you everyone, and I hope and I pray that you and your family are safe wherever you're watching this from. And thank you so much again for spending time in listening to my talk. Let's go 3D with React Native. Thank you.
Thank you, Akshat. That makes me really excited, and I feel like my next startup is going to be AR/VR for sure. Now I have no excuses to not try building AR and VR, right? Because I know how to do it in an easy way. Okay, so now that we know how to build AR, VR, how to do animations, how to make our React Native app run fast, and what are the changes that are coming to React Native, it is time to learn how we can make sure that these changes don't break our production applications. And that welcomes us in the next and the last block today, which is testing. So let's welcome our first speaker in this block, Jesse. And Jesse is currently a full stack developer on Cure App, and he's going to talk about visual regression tests with React Native. Now, visual regression tests are those kind of tests that compare your UI before and after changes and allow you to see how your application, how your code that you are changing as a part of your pull request is actually going to affect what your users see on screen. So it is just another kind of testing that allows you to test a lot of things at the same time, which can be really useful when it comes to shipping your application to production. So let's welcome Jesse on our React Native EU virtual stage and learn more about visual regression testing and how can we set that up in our React Native app.
Hello everyone. Thanks for tuning in. My name is Jesse, and I'm here to talk about the visual regression test in React Native. Here's our agenda for this session. First, I'll be giving a little introduction of myself. Then I'll be going through what visual regression test is all about and how it can be performed on a React Native project. Then I will conclude this session by showing an actual demo of visual regression test using a tool called RegSuit. Hopefully that sounds interesting to you. Let's get started. First, let me quickly introduce myself. Again, my name is Jesse Katsumara, and I'm currently living in Japan, working as a front-end engineer at a company called CureApp. You can also find me on Twitter or GitHub as Natural Clar. I've been developing React Native for the past 2 years or so, and I absolutely fell in love with it. I've been keeping up with the latest updates, and I've been sending fixes to the community repos and the documents, which eventually got me to joining the React Native community, where I maintain some of the main core modules for React Native. I also love participating in other open source communities in general. It's a great way to learn the internals of the project and expanding my knowledge while helping others. I've been helping out with stuff like Japanese translations of documents for libraries like React, Gatsby.js, and TypeScript, and I've been making small fixes to several repositories, including React Native. The company I work for, CureApp, is a leading medtech startup in Tokyo, Japan. In CureApp, we are building a digital therapeutic apps to provide medical treatment with the power of technology. Our engineers at CureApp, we write everything in TypeScript. That is, we write our web applications using React, our servers are running on Node.js, and even our infrastructures are set up using TypeScript with AWS CDK. And of course, our mobile applications are built using React Native. As our applications deal with humans' well-being, we take our testing very seriously to make sure our apps work the way we intended to. I've mentioned that everything is written in TypeScript, so all our code bases are type-safe. We also perform unit tests for the business logics and integration tests for our APIs, and we perform UI testing for our pages and components. For today's session, I'll be focusing more on the UI testing, which the visual regression test takes part in. So the UI testing. When you're working on a big project with multiple people, have you ever felt scared about making changes in a file that already exists? You may think that you've found the right file to solve the particular problem, but you never know if the change will affect something else in your project. Having a test case for your project will let you confidently change any existing file and not worry too much about the effects, as long as the tests are there to protect the code. UI testing is also part of that, and as the name suggests, it aims to test the user interface of an application. It tests the functionalities of parts of application that can be physically seen by the user. Here are some examples of UI testing. If you were to perform a UI testing on a login page of an application, you'd want to make sure that the login page contains all of the aspects for users to be able to log in, no matter what change you make in the code. You'll probably want to have an input form for users' email address, and another input form for users to enter their password, and a login button for users to press once they're done entering their login info. You'd probably also want to verify that the login button is disabled if user's email or password is empty, and it is also nice to test that the login page shows a loading state while the user waits for their verification. And since it's a test for the UI, you'd want to make sure that the login page visually looks the way you intend it to be. As you can see, there are many different aspects of UI testing, and it can be categorized further into different tests like snapshot testing, interaction testing, and today's main topic, the visual regression testing. And let me briefly go through what each of these tests do. Snapshot tests in React or React Native is where you take a component and save the DOM structure of it. so that whenever there's a change to the component, the testing framework can report the difference it made in the DOM structure. Snapshot tests are very useful when you want to see that the particular change you're making only affects the specific page you're trying to change, and it's not affecting any other page unexpectedly. Interaction test takes the page component and emulate what the user would do in the page to make sure that the page performs correctly. For example, if a user tries to log in with an incorrect format of email address, then the user should see an error message and not be able to run the login API. And if the users do enter the correct information, then you'd want to make sure that the information they entered are properly passed down to the API. The interaction tests are useful when making sure the changes in your code are not breaking the user flow. And both snapshot testing and interaction testing can be performed in the React Native projects using testing frameworks like Jest and with tools like React Native Testing Library. React Native Testing Library is an awesome library, so I highly recommend you checking it out. And finally, let me talk about the visual regression test. Unlike the previously mentioned test, which deals with more of a logic part of the code, the visual regression test solely focuses on how the component visually looks. What's displayed on here is an example of test reports generated by the visual regression test. It is showing the change I made in a button component in a way that we can actually see it in our own eyes. You can see that it's showing the diffs of two components, letting you know exactly where the changes are made. And they can also be seen side by side for comparison. How visual regression test works is that first, you take the screenshots of all the pages and components that you want to test, and you store that somewhere you can use as a reference. And every time there's a change made in the component, you take new screenshot of that component and compare that with the reference. And you continue doing that to create visual regression tests. Depending on the visual regression tools you use, I think most of them create reports that, like what's shown on here, every time a pull request is made to the repository. Every report shows the number of components that has changed from the reference, number of new components that are added, or numbers of deleted components if there are any, and number of components that remained unchanged. And once the reviewer checks the report and see that everything is looking the way you expect it to, the reviewer will approve and merge the commit. And once that happens, the visual regression test updates the new screenshot, and the new screenshot will become the new reference. By having these reports, you will be able to prevent any unexpected change that goes into your application, at least in visual-wise. Let me show you a contrived example of how visual regression tests may be useful. Here's yet again a sample sign-up page for your app. And let's say that you have a button in your sign-up page that you feel is a little too small, and you'd like to make it a little bigger so that the user would have an easier time pressing the button. Since the sign-up page is using the primary button component, which takes in a label and displays the button, you go into the primary button component and you see that the width of this button is set to be 150. So you go ahead and change the width of the button to something bigger, like 240, and voila! Your sign-up page looks the way you want it to be. So then you commit the change and you feel good about yourself, and you're getting ready to go home. But you fail to realize that the primary button was also used in the login page of the app, which has a login button and a register button side by side. Since both of them were using the primary button component that you've changed, now the buttons won't fit on the single screen. When you make pull request, the only change filed was the primary button component. So it may be hard to tell from the first glance that the layout of the login page has changed unexpectedly. If you had the visual regression test set up, then it would create a report for both sign-up page as well as the login page, because both of those pages has changed, and you would have been able to tell that the layout of the login page has been broken. That past example can be achieved from a snapshot test as well. You make a change in the primary button component, and it'll cause the snapshot for both sign-up page and the login page to update. So you can catch that you've accidentally changed the layout of the login page. But one thing to note about the visual regression test that makes itself different from the snapshot test is that the visual regression test doesn't care about how component was implemented. That means the visual regression test can prevent false positives that may be created by a snapshot test. In a snapshot test, if you were to make a refactor in your components, like changing your component from a class component to a function component, that will probably require you to update the snapshot, as the DOM structure of the component has changed. Even though the two components may look identical, the snapshot test will change, and you won't know whether the looks of the component changed or not. And another example, if you're using some third-party component library and you want to upgrade the library to the latest version, all your snapshot test of components that depended on that third-party component library may require updating the snapshot. But you have no way of knowing whether the component has changed visually or not. Having visual regression tests will allow you to confidently upgrade your component library and make refactoring to your code with confidence, because it's always taking a screenshot of how the component actually looks in your application even after the change. And also, I want to mention that having these tests set up will help you easily support dark mode with confidence. Let me talk a little about supporting dark mode for your application. With the new Appearance API that has been available since React Native version 62, you're able to check the user's general preference of the app's appearance, allowing you to show the users the app in light mode or dark mode according to their preference. But supporting dark mode means that there are simply twice as many possible screens to verify in your app. And that's how much screens the QAs would need to check. And sometimes, if you're making a change to an already existing app that didn't have light mode or didn't have dark mode, and if you're implementing dark mode, you may forget to apply font colors for a specific part of your dark mode app, making that text unreadable in dark mode. By having visual regression tests for each pages and having tests for both light and dark mode, it will allow you to catch those mistakes rather quickly. So why is it important to perform these visual regression tests? Well, first, it reduces the amount of checks the QA needs to do, so the QAs can focus on finding other bugs in your application. And also, sometimes the difference you make in a component is so small that it is very hard to catch with the human eye. There are a few times where I accidentally enter a character in some pages, and it was caught by the visual regression test. So how do I perform visual regression tests with a React Native project? There are probably many different frameworks that allows you to perform visual regression tests, and the one I use for our project is called RegSuit. RegSuit is an open source testing framework for visual regression tests. This tool will allow you to store a series of screenshots of your components in an external cloud storage like AWS S3 or Google Cloud Storage. And every time you make a new pull request in a repository that has RegSuit integrated, it will make a comparison of the screenshots with what's stored on the cloud storage and the new screenshots that you've made. Setting up RegSuit is also very easy. It provides a CLI command that does everything for you. And once it is set up, it will automatically create reports like the one I showed in the previous slides, listing which screenshot has been modified or newly added or deleted on every pull request. And in order for the RegSuit to work, you need to get the screenshot of your applications. For me, I use Storybook to list all my pages and components for my React Native applications. Storybook is a framework that provides a playground to list all your UI components, and it can be ran separately from your main application, so you won't have to wait for your native app to be built. Storybook has support for various front-end web frameworks, including React, and it also has support for the React Native apps. But actually, I don't use the Storybook for React Native. I use the Storybook for React on web, along with React Native for web library. Using the React Native for web with Storybook provides other benefits, as it allows me to write new components much faster, and you don't have to wait for the emulator to start up. But at the same time, it has some downsides as well, because what's displayed on the web isn't exactly what will be displayed on the native applications. And I'm not aware of other tools that takes screenshot from like an Android emulator or iOS emulator. But if there are ways to take screenshot of your screens from the emulators, then those can also be integrated with the RegSuit as well. And that wraps up the explanation of the visual regression tests. Next, I'd like to conclude this session by showing a demo of RegSuit that's actually running. Sorry, trying to get the demo. Okay. Sorry. There you go. Let's get into the demo. Here's a storybook for a minimal design system repository that I made for my React Native projects. Oh, this is not the storybook. Here's the storybook. Here you go. And it has minimal components, or it has a base level components that are meant to be used to compose component for a bigger project. For this demo's purpose, I'm going to modify this round button outline component and create a new pull request to trigger the reg suit. So here you go. Here's the round button outline component. It's a simple button component which sets styles with set styles, and it takes in a label for the button to display. And I'm going to change the label part to say React Native is awesome no matter what label prop it receives. And I'm also going to change the border radius a little so the shape of the button will change. And then I'm going to commit these change and create a new pull request. Okay, the pull request is made or going to be made. Okay, and then I'm going to let the CI run for a bit. The CI checks the lint and the typing, and it also performs the visual regression test. And while we're waiting for the visual regression test, let me show you how my CI is being set up. So this is the config file for my CI, and this is the visual regression job that's going to be run. And here at the end, I have a command to take screenshots of all the components and pages from my storybook called StoryCap. And then it will run the reg suit once the screenshot has been taken. So let me go back to the pull request and see how the CI is doing. And it seems like everything except the visual regression tests are done. And let me check the status of the visual regression test. And it's about to finish. So let me go back. So this is the generated comment for the reg suit. And it's showing 4 red circles and a bunch of blue circles. The red circle means that there's a change in the component, and the blue circle means that there's no change made. And let's check out the report. All the components that has changed goes on top, and all the components that passed goes on bottom, so you can easily tell which components has changed. And it's nice that you can also look at all the components that has passed as well. It's good for new people in the team to know what components are included in your project. And here's the report screen for each of the components. And you can see here that the left side is the before and the right side is the after. And the text part of the button is changed, and the border radius has also changed. And the reg suit provides 5 different ways to show the diffs. And this one you can slide to slowly see the difference of the app or the component. And there's also, you can also look at the components side by side. And there's an option to blend the components from before to after. That may help you see where it has changed. And there's also a toggle option. And the diff is it's highlighting all the parts that has changed, so you can easily see where in the component that has changed. And that was the story for the dark mode component. And you can also see that the light mode component has also been changed. And you can also, and here is a small login page that I made, which was using the round button outline component that I just edited. So you can see on this report that it's making report for the login page as well. And it also checks the light mode of the component as well. So yeah, that is how the reg suit works. And that wraps up the demo and my presentation. The repository for this demo is also written here in case you'd like to see it in action yourself. Thank you for listening to my presentation, and I hope you enjoyed it. Bye-bye.
Thank you, Jesse. That's been an amazing talk. I'm a huge fan of visual regression tests, and for those of you that are curious, we are actually using visual regression tests in the React Native application. Actually not a React Native application, but as a part of React Native release process. There is a visual regression test that looks at Iron Tester and tries to see the differences. So in case we break the CSS or some important changes to the styling, we can catch these changes early on our Circle CI testing pipeline. So if you would like to follow up additionally to what you just heard, React Native release process is the place for you. Now let's move on to the last talk of today, and that's the talk I'm really excited about. And I'm also biased because it is a talk done by two ColdStack developers, Maria and Mike. And this talk is actually recorded from our office using the same fancy setup that I'm using today to actually present and broadcast live to you. So I hope that you will like it. And they are going to talk about the React Native testing library. Now, React Native testing library is a testing library. What a coincidence that they've been working on. And in this talk, they will talk about why they decided to build it, what are the principles of it. They will talk about their journey, the confusion with other testing libraries in the community, and what is coming soon, and what are the exciting features that are about to ship as a part of the upcoming major release. So let's welcome Maria and Mike on a React Native EU virtual stage straight from ColdStack office to talk about the React Native testing library.
Here comes a testing talk. Hello everybody, I'm Michał.
I'm Maria.
And we work at ColdStack as software engineers, and we couldn't be happier about speaking at this conference this year.
Let's start with how testing of React Native components looked before 2018. We essentially had two ways for doing so, React Test Renderer and Enzyme. React Test Renderer allows us to transform React elements into plain JavaScript objects and perform queries on it. It doesn't use DOM to do so. Its API allows for traversing React component. Paired with Jest, it's easy to generate snapshots out of the output. Let's see it in action. Here is an error message component, which requires title property and renders two elements, message icon and text. Quite straightforward, so let's go to the test. First test is a snapshot. We use create function to render an error message component with set.prop title and convert it into JSON. On the first attempt, test creates a snap of the component. But if we would change something, for example title or class name, on next run, test will fail. It takes time to update a snapshot after each change in the component's UI. Let's move to the next test. Here we're using package APIs to test component properties. And instead of creating JSON, we are using root of the element. I will quickly go through those 3 queries. In the first one, we use find query to get message icon component and check if it contains image element. Next query is more specific version of find. We are looking for component by using its type, in our case message icon. And in the last one, we are looking for class name property to check whether it shows correct title. And you see that those APIs require from us additional filtering. We start from the node to look for properties. This approach is low level today. Enzyme is another popular library for testing React components, which uses shallow rendering. If in case of test renderer, we could go through children of the component, shallow renderer doesn't do the same. With Enzyme, testing is different. Shallow testing renders a component 1 level deep without getting its instantiated relatives. It simplifies the way we get methods of the component, but complicates testing of users' behavior. Instead of actually rendering components and calling its children, Shallow just looks at the properties that would be applied to elements created by shallowly rendered component. In this example, we check whether text value of the first button out of multiple ones switches after being selected. We will see how accessing elements looks with shallow rendering. And you can already know that to access only one element, we should use long path of methods. We start from looking for action buttons and finding needed element. As we have multiple buttons, we should use add method to get the first one. And last step is to get text value of the children. How do you feel about this journey? It took time to get only one component's property. And finally, we simulate the state, doing it directly with the setState method. Such approach feels wrong because users don't do like that. In the next example, we test if filtering by search and tag values matches the output. This will show how we can simulate events with the Enzyme library. First of all, we take our time to create an environment. In this case, it's not enough just to use shallow. We start test from creating new state by updating search query with the tag selection. After that, we directly call an instance getData to get the new state. And last step is to check if the received data is appropriate to our expectations. But there is some magic happening here. If we disable an input, test will pass anyway. As I said before, this happens because shallow rendering is focused on the implementation part more than on real users' behavior.
And late in 2018, a new library emerged called React Testing Library, created by Kent C. Dodds, a well-known educator and creator in JS ecosystem. The library is built on top of a set of helpers to query document object model, otherwise DOM. They started to form a family of libraries called Testing Library, soon adding solutions for Angular, Vue, Cypress, and more. RTL, short for React Testing Library, quickly gained popularity because of not so novel idea wrapped into a nicely prepared package. The idea was to avoid implementation details and testing those, and focus on testing UI exactly as users would use it, and provide developers with tools to help them achieve those goals. The idea was phrased into a guiding principle: the more your tests resemble the way your software is used, the more confidence they can give you. And it determines everything in Testing Library universe. Testing Library tries to only expose methods and utilities that encourage you to write tests that closely resemble how your apps are used. Utilities included in the library are based on the following guiding principles: encourage dealing with DOM nodes rather than component instances. It should be generally useful for testing an application components in the way the user would use it. And utility implementations and APIs should be simple and flexible. So how do you use a testing library to test some React code? Let's see an example. Here we have a React component called fetch. It has some internal state, some logic to fetch greetings with Axios library and dispatch success or error when appropriate. It renders a button displaying load greeting or OK, and a greeting or an error text returned from the server. First, we need to import stuff and dependencies like React, mocks for our APIs, using MSW library in this case, testing library helpers, custom matchers for Jest, and the component to test. We usually need some mocks as well, so now is the time to set up. We mock the server with appropriate responses to our requests, and then inside the test we can declare what we expect from the server to return. In this case, an error with status 500 when calling getGreeting. And finally, a test. We call the render function from RTL and pass it our fetch React element with some props in it. Then we click on the button, same as the user would do, using Fire Event API. But how do we find a button? Using the getByText query, which is a screen helper. And what's a screen? It reflects a current browser document we rendered to. Once we clicked, we expect some async actions to happen, which we were mocking earlier. How do we wait for it to finish? Let's think about our users. They don't know if there's a server call or not. They just expect the heading to show up and show some text after they click a button. So we wait for a heading to show up. We use a getByRole screen helper to find a heading in our current context. Once it shows up, the waitFor function will resolve and let us through. We then assert whether the heading has a text content of hello there, and we make sure that the button is disabled. The toHave content and toHave attribute are custom Jest matchers from a package we just imported earlier. And that's how we write tests in RTL. We think as our user would use the component and use some various queries and matchers to assert on the visible outcome. Notice how we don't care about how fetch component does things underneath. We only care about the browser document being updated appropriately, which reflects what user eventually see on their screens. Now that we've seen a small example, it should be easier to wrap our heads around the API. We have the most important render function, which is responsible for rendering our tested component to the DOM and exposing helpful queries in 3 variants. The variants are get, query, and find. Get is synchronous and throws if it doesn't find anything. Query, on the other hand, will return a null instead of throwing. And find will asynchronously wait for the query to resolve, timeout, or reject. We can query our DOM by various properties and attributes like text or ARIA roles. We can fire event, which simulates user events. WaitFor helpers are for imperatively waiting for something to happen asynchronously. And getQueries for element helps us scope our queries to certain DOM nodes.
We already know that React Testing Library and alike ones are a step forward in testing React and other web frameworks with JavaScript. React Native is mostly JavaScript, so maybe it's possible to create a testing library for it somehow. There was only a handful of challenges to tackle before we would have an equivalent of React Testing Library for React Native. Apart from the library being relatively new and moving fast with features, the biggest issue was React Native not actually being run in a browser that has DOM, but in a custom JavaScript environment. We couldn't really reuse Reactive Testing Library. Because of that, it is required DOM to operate in. As developers, we tend to think about JavaScript as a language that only runs in a browser and has an access to a variety of web APIs built in. It's not quite correct way thinking about it, because browsers are only one of many places that JavaScript language can run in. We call those places runtime environments. If you look at the ECMAScript, you won't see any web APIs described there, not even timers. It's up to organizations like V3C, WhatWG, and browser vendors to specify this. JavaScript can run in other environments, like on server with Node.js or recently published Deno. It can run in a hybrid of browser and server using Electron. It can also run on mobile devices without a browser in a React Native JS thread. Let's explore some qualities of React Native JS runtime and how it differs from the web. React Native typically executes JavaScript using one of these JS engines: JavaScript Core, Hermes, or V8, on a dedicated thread spawned next to the UI thread of your mobile application. To make an environment closer to the web development, React Native runtime injects a bunch of APIs into the global namespace. Global object with the window and self-aliases, timers, which are WhatWG spec, not from ECMAScript, some web APIs like XHR, Alert, and Navigator, React Native specific APIs for performance monitoring, exceptions handling, bridge, and more. And other biggest difference, no document, which means no DOM and all related APIs. Now that we know the differences, we can take a look at JS preset exported from React Native repository. Among others, it has a reference to test environment being Node. This is a way to tell just in which environment to run our JavaScript tests in. Pretty neat, huh? Jest ships with Node for Node.js and JS DOM for browser-like environment with DOM by default. But you can also come up with a custom one if you like. Developers behind React Native figure out that the closest environment to run our tests in is Node. It's also the fastest one, by the way. Side note, if you ever used Enzyme, you may have used JS DOM to run your React Native tests, but it was a hack to work around Enzyme's reliance on web and React DOM. It also resulted in a huge maintenance burden on Enzyme community to mocks up to date. Because of that, Enzyme was very slow to catch up with React Native core development. Thankfully, React doesn't care about where it runs as long as it's a JavaScript environment. The core team provided us with a custom renderer for test purposes to be run in Node.js. We already know that its API is quite cumbersome, but maybe we could address it in a testing library API.
Well, it turned out we could. So behold, the React Native testing library. An initial implementation of the testing library API for React Native. Kinda. Our initial idea and the principles we started from was creating a better testing experience for one of our clients. And to make it easy to migrate off of Enzyme tests that we were using at the time. And we also wanted to render our components deeply instead of using shallow. We decided to go with a thin layer on top of React Test Renderer and wrap it in a React Testing Library-like API, because we felt it was cool. The thin keyword was pretty important here. We already maintain a bunch of other libraries and wanted this one to be as little time-consuming as possible. Once we were happy with the results and how the things shaped up, we started considering publishing the library to NPM. The API was inspired by early versions of React Testing Library. You can notice some familiar exports like render, for example, returning queries and in different variants like get and query. It also rendered update and unmount functions to help with development. There's no find queries because they didn't exist back then. They were introduced 5 months later. Initially, We also exported some other helpers like shallow for shallow rendering, which we added for snapshots. Debug, which then moved to the render output, and flash microtask queue, which was eventually replaced by wait for. What's important in this picture is that even in the first release, we diverged from testing library principles that forbid shallow rendering or some dangerous queries like getting by component type or name or props, revealing implementation details not visible to the users. We introduced these, however, because one of our principles was to be able to migrate off of Enzyme at as low cost as possible. Here is an example of how one could test their React Native components with early versions of the library. We rendered questions board component deeply, regardless it's a class or a function, and imperatively called onChangeText prop to change the text of an input, and then call onPress to submit the form. We didn't implement fire even just yet. Then we check if a verify questions function was called with proper arguments. Today we would write this example a bit differently because we have fire even API. We would also use accessibility queries instead of grabbing components by their internal name. But that's how it was. Already a big improvement over Enzyme because we had deep rendering, there was no difference testing class or function components, and whether they were wrapped in higher order components or not. We didn't mangle with internal state. It felt great. If you ever built an open source library, you probably went with MIT or one of BSD licenses and was done with it, since you were the only creator. At least that was my experience. But not this time. Starting a library from the client's code base on behalf of your employer meant nothing else that the intellectual property of the source code belongs to both parties involved in the project, CallStack and the client. This turned out okay in the long term, but had its downs at early stages of the project, when some decisions were dependent on both parties, and we had to wait for legal departments to agree on certain matters. Interesting experience, wouldn't recommend. We were quite happy with how the library turned out, so we started to promote it in React Native community, write guides and articles. This resulted in a nice and steady adoption and was appreciated by the users. We were adding new features and started identifying gaps that started to accumulate between React Native and React testing library. We've also invested a bit of our time in the documentation. And then, after 6 months of our initial release, a new library comes out of the blue. It's named Native Testing Library. It's the first time we hear about it. It aims to be a proper testing library for React Native because RNTL was, well, not so close to their guarding principles. And it has almost the same API and builds on React Test Renderer. Sounds familiar? You can imagine how confused we were the first time we heard of the library. Nevertheless, you could tell that the developer behind Native Testing Library, Brandon Carroll, put a lot of effort into creating it. From the very beginning, their docs feature a fully fledged website with guides, examples, even cheat sheets. We know exactly how much work is it to create such a resource, and we're nothing but admiring it. It gave us a nudge to improve our documentation as well. Why was it necessary to create a new library according to its creator? RNTL didn't feel like a part of testing library family. Some APIs had slight differences. Brandon wanted testing library tests to pass using React Native implementation. It was also possible with our library to grab non-host components which expose implementation details of the components that we tested, which were not visible to the users. And RNTL also had a shallow helper, even though not widely used. As you can imagine, we had private conversations between us three, me, Kent, and Brandon. We connected through Twitter to discuss how we can push the situation forward. It was a tough conversation to have, as both parties had some valid points. As some of you already know from the past, we eventually ended up having two libraries living side by side without interfering each other. The negotiations failed. So why we eventually ended up with two libraries instead of merging into one? First and foremost, Brandon, the creator of NTL, didn't reach out to us for collaboration. He assumed it would be faster to create a new library for his team use case because he was short on time. That's really unfortunate because we'd happily accept help to push the library towards better compatibility with other testing libraries. Additionally, we were guided by different principles, which we outlined earlier. Our NTL wanted to be more generic library and target React VR and any React that was not rendering to DOM, really. It turned out that we never actually needed such a use case, but we're still open to add support. After discussions with Brandon, we couldn't agree on certain implementation details of our libraries, which would block potential merging as well. We already had a base of thousands of users, and it would be challenging to change APIs without breaking everybody. And last, RNTL was a library created by Callstack, and it was not in the business interest to just throw away the work we did partially for our client and keep maintaining. So in the end, nobody was to blame for this situation. We couldn't agree on fundamental matters important for each of us, and eventually the negotiations had to break. It's sad in retrospect because it was the community that hurt the most, but it was the best we could do at the time, provided the circumstances. The best we could do now is moving RNTL in the direction of testing library principles. We couldn't agree to merge both libraries, so Ken figured out that he'll go with one of the library that's not the more popular, but closest to the testing library principles. The NTL became an official testing library for React Native. I can't blame him for that. It was a hard decision, and NTL was really following the guidelines. As you probably remember or can imagine, soon after, people started to get confused.
So we did the
on
best
why is it
we
like
could do.
that?
At the time, kept on following
It wasn't
the path
clear for
to slowly
developers
deprecate dangerous
that we ended
APIs
up with two
and make
libraries.
RNTL compatible with testing
They wanted
library
answers.
ecosystem.
Why it
That's how
happened.
we ended up with version 2, our biggest and most important release to date. So what is new in second version of React Native testing library? We decided to remove shell rendering because this way of rendering React components is usually not a good idea. We are now automatically calling cleanup after each test. Also, a previous version of getByTestID had a bug, which resulted in finding more test IDs than there were in the native key hierarchy. Your wait for and find by calls are now automatically wrapped in ACT, which helps to avoid read ACT warning in tests involving asynchronous state mutation, for example, simulating page data from API or using animations. Also, we migrated our documentation to use Docus version 2, which comes with a refreshed design, improved accessibility and theme support. Check it out after the talk. New APIs within Helper and Find by queries. Within enables you to perform queries scoped to given element and its children, mainly used for querying list of repeated items or screens. Find by queries are simple, yet useful combination of wait for and get by queries. Useful when you want to wait for some UI element to appear. And also, some additional changes were provided for migration, which need to be mentioned too. We removed global debug function. Now debug is returned from render, and it's all you need. By name, queries have been removed after deprecation for more than a year now. By type and by props queries has been prefixed with unsafe. By the way, those functions are not planned for removal in future versions, but their usage is discouraged. In the first version, getByTestID and queryByTestID could return non-native instances, which was a serious bug. In the second version, we fixed this inconsistency. We have deprecated Flush microtasks queue and plan to remove it in the next major. Nevertheless, we have better alternatives available for you to write async tests like find queries and wait for helper. We like to say that we care about users and we mean it. To show how much, we put great efforts into creating a migration strategy for those upgrading from the first version. We have carefully planned this release for months and smoothed the rough edges of migration, even before releasing the next major version. For everything else, we prepared a thorough migration guide available on our documentation. Complementary to the guide, we have put some warnings around the deprecated or remove functionality to alert users that didn't see that things have changed.
And soon after the V2 release, Kent approached me with this message on Twitter. It's from our private conversation where he's apologizing for the situation that have arisen since releasing the native testing library and reflecting on how we could have done better at collaborating with each other. He mentions that the official library lacks maintenance, while we did a great job maintaining ours. It's a real breakthrough in the communication between the libraries. He immediately offers deprecating the existing testing library for React Native and promote React Native testing library to be an official one by changing its name. What a fantastic message, because this means we're merging two libraries, putting an end to the confusion and doubts among members of testing library and React Native communities. Based on requests from Kent, we both agreed to the following terms and conditions. We deprecate and archive native testing library, rename React Native testing library to @testing_library/React Native, keep source code and documentation under CallStack, and create a migration strategy for both libraries. And of course, we created a migration guide, this time in two versions, one for RNTL users and one for NTL users. We bumped both libraries to V6 to make sure they're even and deprecate the React Native testing library package on NPM. For our existing users, migrating was a matter of renaming the library and one of existing functions. For native testing library users, we've prepared a list of differences and how to migrate to a new library. Prior to releasing V7, we've also made sure to smooth out the rough edges by adding some missing features to V2 of RNTL. Please let us know about the experience when upgrading the library from one to another. We're still identifying small differences and are happy to resolve any issues that arrive. You can hit us on GitHub, Twitter, or Discord under this link. After almost 2 years with the library, we learned some important lessons. Always focus on your users. This is the most important asset your library has, provided it has any. After all, we ship code for somebody to use it. If you believe in your product, keep calm and keep moving. No matter what others do, as long as you keep your users happy. Ease of maintenance is vital to library survival. RNTL is alive today because we don't need to keep up with React Native development thanks to the thin layer on top of stable tools like React and React Test Renderer. Business and open source are mutually beneficial. As a company, CallStack provides developers like me time to develop open source libraries like RNTL. In return, they get recognition and respect from the community they thrive in. But be aware that businesses have their interests. Thank you all for listening. We hope you enjoyed this journey back to 2018 and learned that behind every project, big or small, there are real people. Have a great virtual React Native EU experience, you all.
Thank you, Maria and Mike. It's been an amazing talk, and I'm really pleased to see you presenting on a React Native EU virtual stage. I actually forgot to tell you that, but Maria was doing her first talk ever as well. I think she did great. What you think? So, before we drop off, just a couple of important information for those of you that are still with us after those 8 hours of exciting live stream. Haha! Okay, so, first of all, we have a Discord channel, link is down here. Join it if you haven't done it yet, and that's the place where you can ask us questions about the talks, and we will be answering them during a Q&A session that we will do as a part of our React Native Show podcast, which we also have, so here's the link as well. If you can click it and subscribe, that would be great. Another one must have is obviously following us on Twitter, because we like followings and we like stars. So follow us on Twitter, React Native EU channel, use the React Native EU hashtag to tell your friends that we are live and that they can join us for another exciting day, which is tomorrow. And they can also see and watch the talks that we have streamed today. And don't forget that we have an agenda of the conference at the React Native EU website. Link is down here as well, React Native EU, where you can see the talks that will be streamed tomorrow, and I can guarantee you that they will be as exciting and as interesting as the talks that we have done today. So, I hope that you enjoyed the first talk. I hope that you enjoyed not the first talk, but the first day of the React Native EU conference. And I hope that you are liking the way we are streaming and doing this. If you have any feedback, let us know as well, because this is the first time we're doing that, and we hope that this might be a start to something truly exciting in the future as well. So, thank you for staying with us today, and see you tomorrow, same time, 9 a.m. Wanted to tell you the hour, but then I've realized we are all in different time zones. So, just visit the YouTube channel and you will have the notification that you can click, and that will tell you when we are starting our session tomorrow. So, see you, and thank you for staying with us today.